Hello, superstar. In our first module, we will learn all about Amazon Web Services, or AWS, and we will discuss the early days of cloud computing and take a look at some of the advances that have occurred over just the past few years. This will give us a good view of what the future holds with cloud computing, and that also means you'll get an opportunity to see some of the cool things that you very well could be a part of. We will also take a look behind the curtains to see the core services within AWS and learn about the free tier offerings for their many services. We will also see what the AWS console looks like, feels like, and tastes like. Well, maybe not that last one there, but we will definitely explore the console, and by the end of this module, you will have created your very own AWS account. And of course, that means that's where all the fun begins. So if you're ready for our very first lesson, let's get started. To understand where we are and where we're going in cloud computing, we must first have an understanding of where it all began. This lesson will provide an overview of cloud computing. Trust me, I know these are not the type of lessons most people look forward to, but it's very important, and this should be a lesson that you refer back to in the future. The term cloud computing is well known in the 21st century, but the concept of cloud computing has its origins in the 1950s and 1960s. Businesses first started using mainframes in the 1950s. These massive machines were very expensive, and therefore it was impractical for all users to have their own machine. Therefore, companies introduced the concept of time sharing to make more efficient use of the valuable processor time that was on these central mainframes. Time sharing allowed users to simultaneously access multiple instances of a computer mainframe to maximize processing power and minimize downtime. This technique is the first instance of sharing computing resources and forms the basis of cloud computing today. In the 1960s, a computer scientist named J.C.R. Licklider developed the ARPANET, which is the Advanced Research Projects Agency Network. His vision was to have a global computer network such that users could access programs and data from anywhere. Many of the networking protocols developed for ARPANET form the underlying technologies that are the foundation of the internet today. So we all owe a great debt to J.C.R. Licklider and his team. Cloud computing began to take a more recognizable shape with the introduction of the first virtual machines in the 70s. These virtual machines allowed users to run multiple computing systems on a single physical machine. The first widely available virtual machine architecture was the CP67 CMS by IBM. The capabilities in the early research days led to the concept of virtualization and had a great impact on the evolution of cloud computing. The beginning of the web as a publicly available service on the internet arrived on August 6, 1991, when Berners-Lee published the first ever website. Fittingly, the site was about the World Wide Web project, describing the web and how to use it. Salesforce was the first large-scale example of cloud computing. With traditional software, companies had to buy many licenses and install physical copies on every employee's computer. What Salesforce did in 1999 was a game changer. They allowed companies to access the application on demand over the internet and use it to grow their business, whether they were a small startup or a major corporation. This groundbreaking new approach to software was easy, effective, and affordable, and it set the stage for cloud computing as we know it today. And that brings us to AWS. Amazon launched a beta version of AWS in 2002, but publicly launched on March 19, 2006. It offered two services, one for storage, which was called Simple Storage Service, and one for compute, referred to as Elastic Compute Cloud. Since then, other major technology companies, including Microsoft and Google, have launched their cloud products to compete with AWS. We will be learning all about the services that AWS offers in the very next lesson, but know that these same two first core services from AWS are still cornerstones in their lineup of offerings. Organizations around the world rely heavily on results of Gartner each year. Many decision makers choose products and technologies solely on these results, and I can tell you firsthand that this happens more than one would expect. One of the tools that's used to help decision makers, and a reason why many go to One of the tools that's used to help decision makers, and a big reason why many choose Gartner, is the Magic Quadrant, which provides a graphical competitive positioning of 4 types of technology providers in markets where growth is high and provider differentiation is distinct. In the upper right-hand corner are the leaders. Leaders execute well against their current vision and are well positioned for tomorrow. As you can see in this most recent chart from Gartner, AWS is the leader, and quite honestly, they've been that for some time. Microsoft and Google are also in this quadrant as well. Visionaries understand where the market is going or have a vision for changing market rules, but do not yet execute well. The niche players focus successfully on a small segment or are unfocused and do not out-innovate or outperform others. In 2020, both Alibaba and Oracle were in this quadrant, but over the past 2 years, they've caught up and done some great work, and you can see that they've moved to the visionaries quadrant. Last but not least, challengers execute well today or may dominate a large segment, but do not yet demonstrate an understanding of market direction. But again, for cloud infrastructure and platform services, AWS continues to lead the way. There are many companies that use AWS. Many are shown here on your screen. And highlighted in bold are the top 10 users in 2020. Netflix spent $19 million a month on AWS compute. Facebook spent $11 million monthly on EC2 compute. ESPN, $8 million, and Twitter, $7 million. This statement here from Gartner explains exactly why you're in the right place. According to Gartner, global spending on public cloud products is growing at an annual rate of 20.4% and is likely to reach $600 billion in 2023. To put that in comparison, Gartner predicts organizations will spend nearly $6.69 billion on cloud security in 2023. That's just 1% of what organizations will spend for securing their cloud resources compared to the overall spend on the cloud. So what's on the horizon? What are some of the areas of opportunity that organizations around the world are looking to better our future? You may have heard of AR and VR, augmented reality and virtual reality. Well, that's not going anywhere, and many leaders around the world are betting their future on those 2 segments there. And you may very well find yourself working on some pretty cool and amazing projects. If you're a fan of American football, you may have noticed this year that Thursday night football is no longer played on cable television. Instead, Amazon was awarded a contract to broadcast it online on Amazon Prime. This may be a sign of things to come as it pertains to sports broadcasting, and the verdict is still out on how that will go. The military and federal government both rely heavily on the cloud and healthcare services. As our population continues to age, we continue to find ways to leverage technology and, of course, cloud computing to offer services remotely that don't require patients to have to go into hospitals. But many healthcare services, governments, and federal agencies are continuing to seek ways ahead that could incorporate those by making use of the cloud. As you can see, cloud computing has come a very, very long way, and we still have a long way to go, but the future is very bright. In our next lesson, we will log into the AWS console and take a look at what these AWS Core Services actually provide. So I'll see you in the next lesson. AWS provides many services to its customers. There are over 200 services that are available inside the cloud offering to support businesses, customers, and consumers. But out of all of those 200 plus services, only a handful are deemed core services. Core cloud capabilities are those that most applications will require simply to run, and AWS offers a broad set of global cloud-based products that encompass these core services, and they include compute, storage, databases, analytics, networking, mobile, developer tools, management tools, IoT, security, and enterprise applications. To get a better sense of the difference between services and core services, think about a home. There are certain things within a home that almost any customer or every customer will want and need to make that home a little bit homey. So those essentials might include things such as roofing, windows, flooring, maybe things such as electric. And so underneath each of those main categories, aka core services, that's where there's those additional services. So for flooring, you may have carpeting, hardwood, slab, or some of those vinyl type floorings there. The same for appliances, just the various types of appliances that you have, not only in your kitchen, but throughout your home. And so think of it that way to get a better understanding of the difference. But to get a visual, let's go ahead and hop inside of the AWS console. So this is the home screen of the AWS console. And as you can see up top in your upper left-hand corner, if you click on services, there's tons of services that pop up here. So don't be alarmed. We will definitely go over these throughout the bootcamp. But there's a whole bunch here, and there's even more if we click on all services. As you can see, the scroll bar gets very, very expansive. And this is where we talk about those 200 plus. But just to get a feel, let's go with really one of the primary or search for EC2, which you can either click here if you recently visited, or always search here in the search bar. If we click here, we're taken to really one of the things that we're going to spend a lot of time in as well during this bootcamp. This is where we'll deploy the servers, manage the servers, manage the IP addresses, and the security groups, the key pairs, and things like that. So again, don't be confused as of right now. This is, I know we don't have our account created, but just a quick tour of the services to get a glimpse and idea of what they mean. So within just the core service of compute or EC2, we see here on the left-hand side, there's a whole bunch of services that are right here as well. So again, this window pane may seem over daunting to you right now, but I promise you, by the end of this bootcamp, you'll be flying and navigating effortlessly. But again, that's a quick overview of the core services from AWS, as well as some of the other services. It's almost time to create your very own AWS account. But before we do that, we need to learn about what comes with the free tier account, as well as our responsibilities as an AWS account holder. And to do that, I'll see you in the next lesson. So the last thing that we need to do before creating an AWS account is to learn all about the free services and tiers that they offer. Again, most of the things that we'll be using in this bootcamp are going to come from the free tier. And if ever there's a moment or a service that you need to use that may have a small charge, I will definitely let you know that, so that if you don't want to partake in that, you can just watch the demonstration there. But to find out about these free tiers, go ahead and head on over to Google or your favorite search engine and type AWS Free-Tier. On the results page, let's scroll down a bit and let's right click and open a new tab, this free tier result here. And we'll be reading this one right here. And I'll drop this link, of course, in the notes section. But when this page populates, you can see the 3 different types of offers that AWS offers new account holders. Free trials, apologies there, which are short-term offers. You'll see the duration when we scroll down a bit are shorter than a year. Of course, the 12 months or the yearly ones will be here. And of course, always free. So again, you can sort on these different, or filter, I should say, these different things. But we'll just go ahead and click on a free trial. Let's click it one more time. This will then filter it by all of the services that AWS has that are free tier. So as you can see here, SageMaker, which is used by many across the world, they leverage it for the machine learning capabilities. It's got 250 hours per month. Again, the description will tell you here for 2 months. Redshift, again, cost-effective data warehousing. Many of these have specific models that you have to make sure that you do if you use that. And some of the security features such as Inspector and Guard Duty, these have free trials for 15 days for Inspector and 30 days. And we'll be taking a look at both of these services a little bit later. 12 months. Again, let's click one more time. And these, again, these top 3 here, Amazon EC2, this is the compute. Basically, the virtual servers are taking use of this service. You get 750 hours a month if you use one of these OSs or operating systems, and T2 Micro or T3. And we'll learn all about the different instance sizes in an upcoming lesson. S3 for object and file storage, similar to OneDrive or Dropbox. That's where you can make those files privately or publicly available. And many websites actually for their static material host things in S3 buckets. But you get 5 gigabytes of standard storage there, of course, for 12 months. And RDS, this relational database, this is one of the premier database services by AWS, and many people take use of this. And again, this has the constraints of having to use one of these instance sizes to take advantage of that free tier. So a host of different services provided by AWS for free when you create a new account. So definitely spend some time here, get familiar with the services that are here. And if you ever have any questions or are unsure, then come here to see if that is free. But there's also this tab that we opened, the free tier FAQ. So this one's not a long read. So if you don't mind, just spend just a few minutes, probably less than 5, to just acquaint yourself with the questions and answers that are here. And it may answer some of the questions that you have in your head. But if not, definitely reach out. But they do a very good page of their white papers and documentation of reoccurrently coming and adding to this. So the responses that you see may be a little bit different a few months from now, but they try to keep themselves current with the data. But again, like I said, both these tabs are tremendous resources and they answer a lot of the questions. But these are, again, the free tiers and the different levels for the components and services and resources that are provided by AWS. I'll see you in the next lesson. So now it's time for our very first hands-on lab. And in this lab, we're going to provide additional enhancements and security to the root account that we just created. And we're going to do that in 2 different ways. First up, we're going to use a few monitoring services from AWS to provide billing alarms. And we're going to set a certain threshold so that if ever the resources consume a certain monetary value, that we receive an email notification. And to do that, we're going to access the billing console inside of AWS, and we're going to tweak a few parameters there. Once that's taken care of, we're going to leverage CloudWatch, which helps to monitor services throughout AWS. And then we're going to set that alarm and set a certain threshold. Next up is going to be something called Amazon Simple Notification Service, which is used to send out messages in different ways. And we'll use the email notification there to send any alarms to the root user account and the email address that we specify there. Next up, we're going to enable multi-factor authentication for the root user. The root user is the super user account within AWS, and it's recommended that you only use it for the very specific tasks that require it. You'll see that once we go ahead and take care of these first few enhancements in the next module, we're going to create a secondary user that throughout the remainder of the bootcamp, we will use that account instead of the root account so that we can provide additional protections to this AWS account. So that's what we will be taking care of in the next lesson. And if you're ready, superstar, I'll see you in the next video. So now it's time to finally create your very own AWS account. To do that, go ahead and head on over to aws.amazon.com. And once you're there, click on the Create Free Account button here. Now we need to enter an email address that's personal. This will be the primary email address that will be used for like the root account user, aka your master account. And then you need to select a unique account name. This name can be changed in the future, and it again needs to be unique, but let's enter that email address first. And for that account name, if yours happens to be already taken, then go ahead and just add some numbers to the end is my suggestion. And then once you have that, click on verify email address. We'll need to then head on over to our inbox, and there will be a verification code there, just like you see here. Go ahead and copy that and or remember it and paste it in the verification code box back on the sign up page. And now click verify. Excellent. So now we're at step 1 of 5. The first step again for that root user account is to create the password. As you can see on the screen here, you're presented with the requirements for that password: uppercase letter, lowercase letter, a number, and a non-alphanumeric character. And it must be at least 8 characters long. And you need 3 out of 4 of those requirements. Once you have that, then go ahead and hit continue to move on to step 2. Here you'll need to enter your personal information. I'll go ahead and select a personal account. That's what we need for the bootcamp. And again, this gets you all of those free goodies that we talked about in a previous lesson. I'll pause the video here, but again, enter your complete information. And once you've entered that, there is a customer agreement that you should read here. Open it up in a new tab. And when you're comfortable with those terms, then check the box here and hit continue. Now it's time to enter a billing information, either a credit or debit card. Again, this is going to be to ensure that they have a card on file just in case you ever go over any limits or go outside of kind of the instructions of the bootcamp, as this is your own personal account. But again, we will use free tier for almost all of this bootcamp, and there may be one spot where you can just watch if you don't feel comfortable with the small charge that you may incur there, and I'll definitely let you know that. But you may see a $1 hold, 89 cents or something less than $1 in the next 3 to 5 days just to verify that. So I'm going to pause the video while I enter this information. Once you've entered your billing information, then hit verify and continue. And that'll take us to step number 4. Here we just need to confirm our identity. Go ahead and enter that phone number. And of course, the contents of the CAPTCHA box for a security check. You can hit this refresh button to get a different set of characters there. Sometimes they are tough to read. And once you have it, hit send SMS. The SMS code will look just like this. So let's go ahead and enter that which is what we receive on our phone, and then hit continue, but don't enter this code. It'll be the one that you receive on your phone. And then the last step before we are able to log in and our account successfully created is to sign up for the AWS support plan for this bootcamp. Basic support, the free one, is definitely more than enough. This allows us to create a support ticket, as you can see here, for billing issues and account issues only. We do get access to their resources and white papers and this personal health board dashboard. The trusted advisor will be seeing that in future lessons and learn how that can help us out. But while we're here, you can see the other tier options, as well as the top level enterprise support, which is currently $15,000 a month for organizations to receive any kind of support within 15 minutes. So this is for large organizations with, big tier architectures that definitely need this support because of the critical applications that they have. But again, basic support, free. Keep it there on the default and hit complete sign up. And of course, congratulations, you now have your very own AWS account. So let's go ahead and go to the management console and go ahead and sign in with the email address and password that you signed up with. Keep it root user for now, as we will create a second user in a future lesson. And let's go ahead and enter this CAPTCHA code and hit submit. And then the password, of course, that we use to create our account. And once we sign in, bingo, you're brought to the AWS home console screen. And this is, again, where all the magic begins. So now that we have that, again, a blank slate, first time logging into this account. So let's go ahead and, like we said, let's set up that billing alert. And to do that, there's going to be three things that we need to do. First, here in the upper right-hand corner, click the arrow beside your account name and then click Billing Dashboard. This again will allow us to get alerts for the threshold that we're going to set. And my suggestion will be $1. So in the event that ever you're charged more than $1, if you spin up accidentally a resource that you didn't mean to, and it's more than $1, you'll get an email immediately based off that alert. Now from the billing dashboard, click on Billing Preferences. And again, these are those choices that you see. I would suggest checking all three, but we do need this last one at a minimum, receive billing alerts, and go ahead and enter the email address that you want to receive that, preferably, or I would think the email address that you signed up for this account, but maybe you want it to go to a separate one. And once that's all good, hit Save Preferences. And that's, again, the first thing that we need to do. Let's go ahead and go back to the home screen, which you can do at any time by clicking on this icon AWS right here. The second thing that we need to do is go ahead and create that alert. Those alarms, those alerts are actually underneath CloudWatch. So search for that here in the search bar. And let's go ahead and click on alarms. CloudWatch, of course, monitors resources all across your account. And again, we can set up these various attributes here, but alarm is what we need to do here. So hit create alarm, and then here select metric, click next. And then these are the categories. So let's click billing. And out of these two, total estimated charge. And then the default is US dollars. Let's go ahead and select that for this example in the bootcamp and hit select metric. We can leave the metric name default as well as the currency in all of these items for now. But again, I suggest setting that threshold to $1 just in case something happens or something that you accidentally deploy on your own time. And then go ahead and click next. Now from here on the configure actions underneath send a notification to the following SNS topic, click create new topic. And again, for now, just for this lesson, let's leave this default and then enter that email address one more time. And then it's important to go ahead and click create topic once you've entered that email address. And then let's go ahead and click next. The alarm name, let's just go ahead and enter billing exceeded. And then let's hit next. And then we'll preview what we just configured. For now, again, it's just that $1 is the condition there. And then let's hit create alarm. Now, as you can see here, you're noted to, you need to confirm that change. So again, that's what this warning will be as well. So head on back over to that email address that you entered, and then just click on this link to confirm that you want that topic to be created. And then bravo, there's your very first SNS or simple notification subscription, again, for the billing alert that you have there. So that's all taken care of. Let's view the SNS subscription. And as you can see there, that has been confirmed. So now in the unlikely event that you exceed $1 again, I know I keep bringing it home, but again, this is just to ensure that we have that parameter set up so that you're always notified. Even if you elect to keep this account beyond the bootcamp, and let's say, you know, months down the road, you start playing with things on your own, it's good to have this kind of threshold, and you can come in here and modify that in the future by clicking edit. Now, the last thing that we want to do is to secure our root account. And again, to do that, let's go ahead and head down here. We're going to get into this at a later module. We'll learn all about the security features here, but security, identity, and compliance is the section here. IAM more specifically. And then this is where your users are managed and where you can group them into groups and then assign different permissions to them. So you see this warning right here to add MFA or multi-factor authentication, which is a strong suggestion to ensure that there's security. So in the unlikely event that your account is compromised, someone gets that password without the phone, your phone number that you put here, and being able to enter those 6 digits, then, you know, they won't have that. So let's add an MFA device here. And you may have seen this on the job or for banking websites or things like that. So let's go ahead and hit activate MFA. And then let's select a virtual token. And we'll go ahead and name this. I'll name this Google Authenticator. You can give it any name that you want, but hit continue. And then with your device's camera on your phone, you want to just go ahead and install the application. Google Authenticator will be what I'm using here. And once you hit show that code, you can hit the plus sign or just use your camera and scan that QR code. Once you do, you'll have the codes that prompt up and it'll look something like this. And again, these codes will change every 15 seconds or so. But let's go ahead and enter the first one. And then we have to wait, like I said, about 15 seconds to enter the second one. And then once that's done, we'll log out and log back in just to show you that we've successfully done that. And that's a good check that you want to do to make sure that it's working as intended. And so here we go. And then once you've entered 2 consecutive codes in a row, hit assign MFA. And there we go. So there we go. So now if we come back out to users or the dashboard, the root has MFA. There we go. So now we're all green. And so let's, again, to check that and to ensure it, let's go ahead and sign out. Let's go ahead and log back in. So I think AWS didn't like incognito. So let's go ahead and log in with just a regular Google Chrome session. Again, let's enter the CAPTCHA, password, and Let's go ahead and enter the code, which is getting ready to change on my device. And let's see. So great job there. Again, kudos to you for creating your very own AWS account. And not only that, but you successfully enabled a billing alarm so that anytime the resources consume more than $1, you're alerted via email address. So, that's amazing. And like I said, to secure that root account, that's awesome, because most organizations definitely need to ensure that all of their accounts are protected. So you now know how to do that for that root account, but the process is going to be the same for all of those users. So you've got a leg up there. And like I said, you come a long way in this very first module, but we've got one more lesson, and that's going to be a quick tour of the AWS console. So I'll see you in the next video. So now that we've created our very own AWS account, let's go ahead and take a look at the management console so that we can get familiarized with what's to come in the upcoming lessons in the bootcamp. Starting in the upper right-hand corner, we see the account name that we created during the account setup process, as well as the account ID. The account ID is very important, and whenever you create a support ticket with AWS customer service, they're definitely going to want this to reference the proper account. The account has loads of detailed information about the account, and if ever you want to close the account, this is also where you would come to do that. Organization for an enterprise that operates different AWS accounts. This is kind of how they use a hierarchical structure to use a main or primary account and child or sub accounts to push policies and make it easier to manage multiple accounts. The service quotas section are certain limits, some hard, some soft, that are set up by AWS. For example, the default number of VPCs, or virtual private clouds, that can be created is 5, but you can open a case to increase that number. And there's a lot of other soft limits that you can request and increase as well. The billing dashboard, we of course saw in our last lesson when we were setting up our account, and that's where we set our preference to email us whenever we had any of those alerts that exceeded $1. And so there's other information there. It's a very important section to come and take a look at the bills and see free tier usage and things like that. Underneath the security credentials, if ever you needed to change the password or the MFA settings, this is the easiest way to do that instead of going through the IAM service. So it just saves you a few steps there. And of course, the settings have a lot of preferences for customization and layout and visualization of this account. The region, of course, Northern Virginia, is what we will be utilizing throughout the bootcamp. But for a customer that was in another continent for an actual production environment, they would typically deploy their assets and resources in a region that's closer to where most of the resources will be utilized, so that they can have the best experience and performance for the users of their applications. Coming here to our support, if ever a ticket needs to be opened, this is where, of course, we would go to do that. Again, with the free tier, it's just account specific information and billing that we'll be able to get help with. But the documentation, training, and of course, feedback, these are the other areas that are in this section. If ever AWS was doing maintenance or in a production environment, there's times where they need to move loads or shift them from one server to another, and those notifications will be displayed here. Even if you were to have anything that's in your resources there, the event logs will be the best place to come and get an idea of there. If there's any instability of a node, which doesn't frequently occur, but again, the event logs will capture that. The AWS Cloud Shell, again, we are in the management console, so everything is graphical. It's a little bit easier to learn that, but we will be using the command line, or the programmatic way of doing the same thing that you can do in the management console. So there are very few commands that have to be done in Cloud Shell. For example, we won't touch upon in this bootcamp, but the gateway load balancer is a service that has certain commands that have to be typed here. There is no way as of this video to do that in the management console. But we can do some Linux commands here, like see what our present working directory is. And don't worry, we will definitely get familiar with the basics of Linux. So don't let this intimidate you. If we needed to make a directory like tests, we can go ahead and list that and of course navigate to that. And let's make something text test.txt, just an empty file there. And we'll go ahead and see that right there. We can also do AWS commands, such as if we wanted to spin up an EC2 instance or create an S3 bucket, we could do that as well. But let's go ahead and get some information about the default VPC that's created in AWS. Let's see. Apologies there, needed the S at the end. So we will get into this. This is a networking component, and this is where the IP address space comes into play. But by default, AWS does provide each account a default VPC. But this, again, is just to show that we can do Linux commands as well as talk to or communicate with the AWS side of the house programmatically or via command line. So let's go ahead and go back to the home menu here. We saw earlier in the overview, the services section here again. There are so many here, and of course the ones that we frequently visit. If, for instance, you were responsible for the budgets, then you could hover over this, click this star, and let's say you wanted to also monitor the resources and easily know how to get there, place that one here. And as we can see here above in the upper left-hand corner of the tile, your favorites are placed right there. Along with the console home, there's also, if we scroll down, some additional information. We've not yet deployed any assets, but we would get statistics on those resources here, as well as the health of the network. There are also some quick tutorials on how to do some of the simplest things and the quick way they give you an estimate on the time that it takes here, as well as trusted advisor that we saw. This is something that we're going to come back and revisit in a little bit more detail in a future lesson. And so again, also some more additional information on things that are coming up. AWS reInvent will be here November, coming up here right after Thanksgiving. So there's a lot going on here on this page, but again, just wanted to give you a welcome here. So feel free to navigate around and see what's behind the curtain since you have your own AWS account. But we will be exploring the AWS console in and out throughout the bootcamp. But don't worry, we're going to dive a little bit deeper here in the upcoming modules. So now that we have created our very own AWS account, what would it take to create several user accounts for an organization? How can we create them and securely provide them access to different resources depending on what group they're in? These different aspects and so many more are what AWS's Identity and Access Management, or IAM, is all about. In this module, we will explore each of the elements that you see here and learn what each refers to. We will also explore the link between creating users and groups and learn how to assign them individual security credentials. We'll then move on to exploring how to grant permissions to a user by creating an IAM policy, which is a document that defines the actions of allow or deny and resources that an entity can invoke. By that time, we'll have plenty of experience manually creating user accounts. But to take it to the next level, we will take a look at a customized script that will allow us to automate the entire user account creation process. Even if our organization asks us to create 100 user accounts, no problem. And although we have seen how to set up MFA with our very own AWS root account, we will see how to create a policy that enforces users to set up MFA, or else they will not be allowed to access any resources until they did so. That's a lot to take in, so instead of letting it marinate, let's go ahead and get right down to it. It seems that no matter where you look, over the past decade, large organizations around the globe have fallen prey to data breaches at one time or another. This article shows that in 2017, Deloitte, one of the biggest accountancy firms in the world, fell prey to a cybersecurity attack. It was found that hackers breached Deloitte's global email server via an administrator account that had unrestricted access to the entire network. The account did not have MFA enabled, and we learned early on when we created our root user why MFA was so important for privileged accounts such as this one that had access to the entire network. The purpose is not to single out Deloitte, but to show how susceptible an organization can become when poor IAM processes are in place, and more importantly, when they are not continually audited and corrected. Andrew Martins, a staff writer for Business News Daily, reported that poor access management leads to the majority of IT hacks. But what exactly is access management? Great question. Identity and access management is a web service that helps you securely control access to AWS resources. IAM identities determine who can access resources in your AWS account. Users and roles are the primary identities that we will explore in the next slide, but it's also good to know that principal is another term that's often used to refer to an IAM identity. Access management or authorization inside of IAM is what stipulates the resources that can be accessed, and it's controlled by policies which grant permissions. An IAM user is an identity with an associated credential and permissions attached to it. This could be an actual person who is a user, or it could be an application that is acting like a user. We will learn how to create users in our hands-on lab, and you'll become very familiar with the different characteristics that are present. A collection of IAM users is what's referred to as an IAM group. You can use IAM groups to specify permissions for multiple users so that any permissions applied to the group are applied to the individual users in that group as well. In our hands-on lab, you will see how managing groups is quite easy. You set up the permissions for the group, and those permissions are automatically applied to all users in that group. If you add another user to the group, the new user will automatically inherit all the policies and permissions that you've already assigned to the group. In an organization, this lowers the administrative burden. IAM roles fulfill a unique and powerful niche in the identity and access management landscape. Instead of assigning permissions to an entity directly, roles allow an entity to be granted permissions temporarily on an as-needed basis to perform tasks. For example, you might allow a mobile app to use AWS resources, but you do not want it to save the key or the password. Or you may want to give access to resources to a user who already has an identity defined outside of AWS, such as a user who has Google or Facebook authentication. If you want to provide someone with a service or let someone access resources in your account, you can use roles for that purpose too. This may be needed in circumstances such as when a consultant or an auditor needs temporary access to be granted. They're not permanent users. They just need access to the environment to perform the task. An IAM policy sets permissions and controls access to AWS resources. Permissions enable you to perform actions on AWS resources. When a new user or a group is created, again, it has no permissions and a policy must be attached to allow actions to be taken on AWS resources. You can assign permissions to all AWS identities, users, groups, and roles, and we will see the 2 ways to assign permissions in the upcoming hands-on lab. A few of the key IAM features are seen here. We've already discussed the importance of authentication and authorization, and we will also see how fine-grained permissions can be provided to get very granular when providing permissions to ensure that the least privilege concept is enforced. Although we will be using a single account during this bootcamp, in the real world, many organizations have multiple AWS accounts that they either utilize or that they are responsible for managing. And IAM is critical to ensuring that there can be shared access across these accounts. You have probably seen a page like this somewhere along. You may be familiar with the screens such as this, as you often see online for retailers, blogs, or social media sites. Clicking on a button such as this is a form of using federation in the background. To make it simple, instead of creating hundreds or thousands of users within AWS, there may be times where you trust a partner site or customer. You can create a tie between the directories and establish that trust so that they can log in with their already created accounts inside of that respective provider, such as Okta or Active Directory. This was a great overview of what IAM is and the different elements that are a part of it. But now it's time to head to the console and explore how it all ties together. I'll see you in the next video. Organizations everywhere need a way to efficiently organize and manage their users. This is typically the role of one or more teams within an organization as they take on the responsibilities of creating, deleting, and managing users within an organization. AWS IAM provides a lot of tools that makes it a little bit easier for them, and we're going to explore users, groups, and policies here in just a few moments. I recommend that you go ahead and get logged into that AWS account that you had and just go ahead and follow along. But let's go ahead and get right into it. As noted, these organizations typically have different teams structured to do different responsibilities. Account creation is not the only thing that's needed in organizations. There may be a team that's responsible for managing the database, and there may be another team that's responsible for securing the S3 buckets, some of the websites, things that are there, and ensuring that the policies don't allow too much permissions or access to those buckets that may be publicly facing. Another team may be the network team that's responsible for managing and creating the subnets, routes that go across the transit gateway, and maybe allocating IP addresses to other teams. Each of these teams, or these groups that we should say, need to have only those specific permissions that they require using a concept known as the least privilege. We just read about Deloitte and what happened back in 2017 by having that account that had access to the entire network. And that's what we want to do away with by creating those groups and only applying the least privilege permissions. So in this hands-on lab, we're actually going to hop into the console and demonstrate creating the groups. As you can see here, we've got 4 groups: the cloud admin, the database admin, the server admin, and the network admin. Each of these groups will have one-to-many users that of course receive those permissions that are granted within the policy to allow them to access resources inside of AWS. We'll take a look at creating these groups and of course tying the users to them, and then of course attaching the policies to those groups, and then of course we'll see what that gives us. So let's go ahead and get logged into the console. All right, here we go. Once you're logged into the AWS console from your home page, if you've already visited that section, again, this widget here is going to show some of the most recently visited services. But if you've not been there yet, then go ahead and click on services. You can either scroll down to security, identity, and compliance, or go ahead and type in IAM, and then this will bring up the page that we need to go ahead and get to. Most, if not all, of the items that are really tied for the day-to-day responsibilities of anyone that's configuring IAM are hosted right here on this page. The root user has MFA. We did that in the last module, in the hands-on lab there. But again, it's great policy and good practice to go ahead and enforce that for all users, not just privileged users such as the root user. And we're going to talk about that in the next lesson as well. But here on the left-hand side, underneath access management, you see the user groups, the users, and the roles. Now, this is kind of a chicken or an egg type of scenario, as there's nothing really wrong with creating the users before you create the groups or vice versa. But in our example, we're going to go ahead and create the groups first. So let's go ahead and click on user groups. As you can see here, there's a create group button right here. And so let's go ahead and click on that as we have no groups that are created. We need to give that user group a name. And again, we're going to go ahead and follow those 4 group names that we had earlier. We're going to create them right now, starting with the cloud admin. If we had created the users first, this is where we could add them during this step right here to reduce one of the steps. We'll come back here to attach the permissions and policies, but as you can see, 785 as of today, different managed policies that can be attached. And of course, the option to create your very own policy. But we will do this in the very next step. But for now, let's just go ahead and create those 4 groups without doing anything else. So if you're logged in and you've already typed in the name of Cloud Admin, go ahead and click Create Group. That's going to be our very first group that we've created. Again, there are no users that are tied to this group just yet, and the permissions have not yet been defined. But let's go ahead and repeat this step 3 more times. Again, our next group is Database Admin. Again, if you're following along with me, I appreciate that. Let's see what we got here. But if not, like I said, definitely can come back and watch this video and try it on your own. And like we noted, IAM is free, so feel free to practice looking and playing around with the policies here, but try not to create any resources outside of the bootcamp so that we can not be charged. Our 4th group, network admin, is the last one there. And once we hit create group, then we have our 4 groups created. So we see here there are no users tied to these groups again, and no permissions. But let's go ahead and talk about permissions that are here. Again, the permissions come from the policy. So let's think about what a cloud administrator may need. In our theoretical or hypothetical, I should say, organization, our cloud admin is going to be able to basically have full administrator rights. So once we click on Cloud Admin, let's go ahead and come to the Permissions tab. Once we're here to attach a policy that's already managed by AWS, let's click on Add Permissions and then Attach Policies. And again, those 785 are still here. But let's go ahead and type in admin and hit enter to search for that. This will filter, of course, those permissions that contain the word admin. And there's 2 pages here. But the one that we need to attach to our cloud admin is going to be administrator access, which provides full access to AWS services and resources. So to do that, go ahead and check this box here and then click add permissions. Once that's done, you can see that now we have 1 permission that's attached to this group. If you're curious at what this permission of administrator access really provides, then JavaScript Object Orientation, or JSON, is what this format is here. And we'll talk about that a little bit later. But this, again, the star is pretty much all. The effect is going to be allow or deny. And so this policy allows the users that are part of this group to basically do anything. The actions may be something like get, push, list buckets, things like that, but it can do anything. And the resources are, of course, is it a specific S3 buckets, all S3 buckets, a specific server, all servers? It can basically access any resource. So with this policy, an easier way to visualize that is to go ahead and click on this link here, but we've done that in a new tab. And once this opens up, it's going to display kind of easier to understand for some instead of that JSON format there. We're going to see listed here out of those, was it 780 plus? I think 785. We're going to see those listed here. So 340 out of 340 services. It's basically, again, allowing administrators to do that here. So let's now go back to our groups again. We've attached the policy to our very first group, the cloud admin. So we need to now find and think about what access the other three need. Again, these will be specific and given to you by your organization, so you don't have to think about it, but now we're just putting our thinking caps on. And let's go ahead and click on the database admin. So the database administrator, let's say that they need full access to one of the most popular databases, which of course is RDS, relational database there. So let's follow the same process. Click on the permissions tab, attach policies, and let's again filter for RDS and hit enter. Again, just one page of results here, but our DBAs or database administrators need full access to that service. So let's go ahead and check that. We'll click add permissions. Again, we'll come back to user groups. We got 2 more remaining. Our network administrators. The primary service that most network administrators stay in and out of is what's called the virtual private cloud, or the VPC. So let's go ahead and type VPC to filter for that. And again, they need to administrator that, so they need full access. But they may also need to see the servers. They may need to see the security groups and things that are listed underneath the EC2. So let's filter for EC2. Oh, apologies. Let's go to attach policies. And then let's search for EC2. And then our server group, our server admins, the very last group we're going to create, is going to be responsible for managing and, launching those. But again, this network admin, they need to be able to see it. So let's not give them full access, but let's give them read-only access. And then again, let's go ahead and hit add permissions. And now this network admin has 2 permission policies for that group. It may be a little bit special if you're a network person. So let's go ahead and click on the very last group, server admin. Let's do the same, click on the permissions tab. And again, you do this enough time, it becomes a little bit easier. Let's go ahead and filter for EC2. And so I encourage you to kind of play around with this a little bit outside of what we're doing here, just to grasp and get that better understanding and familiarity. So now all 4 groups are created. Each of them has a policy attached to provide the permissions. Now all that's left is to create the users and to then associate or tie the 2 together. So to do this, let's go ahead and create a user. Now what I want you to do is, if you recall in our last module, even right now, you're logged in with the root administrator or the super user. That's not best practice, only when you really need it, which is very infrequently once you've created another user. So what I want you to do is think about a username, and let's go ahead and type that. This one I will put for myself, Cloud Admin 1. But I want you to think about a username that you can remember, and for the rest of the bootcamp, this will be the login that you'll use instead of the root account. This user needs, let's go ahead and provide them with console access. This is going to allow them to visually see the console just like this. We'll get into the access key a little bit later, the programmatic way of using the CLI primarily, and of course the APIs. As far as the auto-generated password, you have a choice of creating a strong password here or letting AWS select one. For us, we will select auto-generated password, but I suggest that you go ahead and create your own password that you remember. And then once we have that done, for this one right here, you don't need to change that password at the next sign on. And once that's done, let's go to permissions. Now, because we created those groups, again, we could have did it the reverse way, but let's go ahead and add this account that you're creating right now to the cloud admin group. And for tags, we don't need any tags, but you can, this is where you can search, filter, do billing things for, like perhaps you want a tag to be called department, and this would be, you know, the cloud team or something like that. But for now, let's not put any tags here. Let's review and let's create this user. It's going to give you the choice of downloading this CSV. Again, we don't want to click on show password in case there's anyone around us if we were doing this at work. And we can send an email if this was for other users. But for now, let's download this again to get that password and of course the login URL. So very important, go ahead and click download there. Let's go ahead and close this. Now we got 3 more users to create. Again, for each of these, we will also go ahead and create them and give them access to the console. So let's go ahead and click add user. Next up, the group is database admin. So again, we will respectively name this user database admin 1. We'll give them that console. We will let AWS auto-generate the password. For a user in a real organization, we would require them to change their password at the next login. But this again is just getting a familiarity. So we're just gonna deselect that. Again, let's add them to the database admin group. No tags, and let's click review and let's create that user. We'll download the CSV, and then again, we'll repeat this 2 more times. So I'm going to pause this video, but go ahead and create the remaining 2 users, the server admin and the network admin, and just follow the same naming convention. But just to speed up the video, I'll go ahead and create those 2 users right now. So now we've created 4 different users, and we've tied them or associated them to 4 different groups that have their respective permissions and policies attached to them so that they can only access the resources that their team and the organization requires. This has really been a leap forward, and we've come a long way in just a short period of time. One last thing before we get away, I created a user group here just to show you, similar to many menus that you'll see across AWS, what happens if you don't want one or if you errantly created a user or a group. In that case, just go ahead and click on this box here and click delete. And a lot of times you're going to be asked by AWS, just as an extra check to make sure it's not an accident, to go ahead and type the name of the account. You can copy that or type it in. And the same would be when you're ready to delete a server that has protections there to make sure you're not accidentally terminating it. But I'm very proud of the superstar that you are and the amazing cloud professional that you're becoming in just a short period of time. In the very next lesson, we're going to do our very first project, and I cannot wait. So if you're ready, I'll see you in the next lesson. Welcome to our very first project. I'm super excited for this, and I hope you are as well, because during these projects, this is where the rubber truly meets the road. We take all that knowledge that we just gained during the previous lessons, we apply it to a real world scenario, and we challenge ourselves to think creatively to come up with solutions for real world problems. These are the type of things that hiring managers, HR recruiters, and of course, when you ultimately become a part of the tech world, these are what your teammates are going to look for you to be able to help to bring the organization forward. This actually is a real world example from something that I had to go through during a project, and so let me go ahead and explain. You may think that the groups that we created during the previous lesson actually had no real world use, and we were just beginning to understand about users, groups, and permissions. But to be quite honest, these are things that teams all over the world every day not only need to know how to handle, but also these are actually things that companies need to be done to get the job done. So if you weren't able to create the 4 groups that you see here, then I would encourage you to go ahead and pause the video and go to the previous lesson where we walked through, demonstrated, and actually created those 4 groups, because you're going to need them to complete this first project. A few years ago, my director actually brought me into his office, and I didn't know what to expect as I had no heads up. But he talked about a special project that he wanted me to be a part of, as he thought that the skills that I had would allow me to be a valuable contributor to it. So myself and one other engineer began to get the requirements, and of course we dialogued back and forth to see if it was a possibility. So an AWS account was created for me and my partner, and of course we were off to the races. Let's go ahead and fast forward a year and a half, and let's just say that things accelerated quicker than we ever could have thought. Not only did we successfully architect the solution, but we actually started taking on new tenants and new clients. And that was amazing for the company. But again, it was tough to flex in and out as we had our regular job. So in the real world, a lot of times you'll have special projects that you need to lend your hand to. And if successful, you still have your primary responsibilities to handle. So in that case, we needed to find a way to create users for these new tenants so that we could easily hand that off and of course document that process to make it easier for anyone that came along and that was their responsibility. So in this real world example, we're going to take a facetious company called NYF, and we're going to pretend that they just won a contract and they have a tech team of 50 plus users who only have equipment in an on-premise data center, but they're beginning to expand into the cloud. And their work, of course, requires them to have AWS Cloud's account. Their HR manager has a spreadsheet that contains information about each of these team members, such as their email address, their name, and which department they are. The question is, can we take this spreadsheet and find a solution that can automatically create users within their new AWS Cloud account? So in part 1 of this project, we're going to actually use the script that I created a year ago to help make it easier for my team. We're going to break it down so that you can see how easy it is to not necessarily think outside the box, but to get the customer requirements and to think of a way to make it easier for yourself and your team. That's definitely the definition of a true cloud professional, to not only think about yourself and what you have to do day to day, but to think about how you can make it easier for the entire team in the organization and for those that will come after you. So we're definitely going to do that here. In part 2, we're going to actually secure these accounts. We're going to add not only MFA, but we're going to see how we can actually enforce the users to change their password and talk a little bit about the password complexity requirements and see how we can change those depending on what the organization needs. So if you're ready, I'll see you in the next video. Hello, superstar. Welcome to our very first course project. Before we get started, let's go ahead and do a quick recap so that we can be sure what the customer requirements are for us in this project. If you recall, Network Your Futures Incorporated is currently located on premise in a data center, and they are seeking to move into the cloud in a new AWS account. They have asked us to create new user accounts for all 50 of their tech team members. We've already gone ahead and created the groups ahead of time to make things a little bit easy, but they've also asked that we can create a customized script that will help make the user account creation process a little bit easier for them and their staff. But they've also asked that we ensure that security best practices are maintained. Their organization has one hard requirement, and that's to ensure that all user accounts have passwords that meet this minimum complexity. They must be at least 16 characters, and they must also include at least one number and one special character. They've also asked that any other security best practices within the industry be adhered to. So we're going to do a few things to ramp up their security posture, and we'll do that in part 2. In most customer engagements, at a minimum, there's going to be a validation and reporting done at the conclusion of any project. For this small engagement, they've simply asked that we provide a brief report on the actions that we took to meet each of these requirements. So we'll touch on that at the conclusion of this project. So let's head on over to the AWS console and again, get logged into your very own account. And from the home screen, if you've already visited IAM service, which we have, you could click right here. But again, recall at any time you can search any keyword in the search bar up top, and you can get to the IAM dashboard from there as well. The first thing that we want to do is ensure that the 4 groups are created and be cognizant of what those names are. So let's click on user groups. So we're good to go there. The HR manager for their company has already sent over a spreadsheet containing information about all 50 tech team members. So let's go ahead and open that spreadsheet. This is what it looks like. And so let's go ahead and highlight these first 3 columns, double click the middle of the column headers so that we can get a little bit more space and zoom in a bit here. And let's see. So the first column, of course, has the name of each of those employees. Second column has their email address, and the third, the department that they work for. So to meet that first requirement and to have a script that's going to automate the user creation process, we need a way to ensure that the information contained in the spreadsheet can be read by that script. We're going to look at that script in just a few minutes, but let's think about this. Inside of the console, when we created a user, we needed to provide a username and a password. Once the user account was created, we needed to then associate it to a group. So to get the username out of one of these 2 fields, we actually don't even need this first column. So let's go ahead and delete it. And then we can actually use the first part before the @ symbol, which is a standard naming convention in most organizations. First name dot last name. So to remove that on a Windows machine, let's hit Control H and let's go ahead and type @nyf.com, which is the domain. And let's replace everywhere that is with nothing. So we'll hit replace all. And as you can see, it's replaced all 50 instances of that. Let's go ahead and right click and remove that. We don't need it to be a hyperlink. Now for the departments, we see that these actually could be used for the group, but they don't actually match up with the names that we have, but they're a little bit close. So let's see what we can do. Again, eyeballing this, DBA is a database administrator. So to make that name conform with what we have, let's go ahead and find DBA anywhere in the spreadsheet and replace it with database admin. And let's replace all. We'll do the same for architect, which is going to be our cloud admin group. Network engineer. This will be our network admin. And the last one is systems administrator. Let's go ahead and just copy this one, a little bit long. And let's go ahead and replace that with our group name, server admin. We'll hit replace all here. And as you can see, this looks pretty good now as it conforms with our naming convention. The last field that's going to be needed is a password field. So let's come here, and because we actually will end up forcing all of the users to change their password in the second part, we just need to create one that can be common amongst all users. In the real world, what we would do is we would compose an email, and in the BCC, blind carbon copy section of the email, we would actually include all 50 users there. But when they get the email, it'll look like they're the only one in the to field. So they won't even know that the other 49 users have the same password. And because we're forcing them to change their password upon the first login, this is kind of a standard method that's used within the industry as well. So let's go ahead and just come up with one, let's say something like this. We'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, and pound. And again, we will copy that to the other 49 users there. Now, we've not yet looked at the script, but the reason that I will change this email field to user, this department field to group, and of course, the added column that we created, password, is going to be because the script needs to read these in this form. So that's really all that's needed. And this could be 100 users, 500 users, 1,000. But we now know the standard of how we could do this regardless of what the ask would be. So now let's save this. Again, we need to ensure this is a CSV. Again, you'll see that there's multiple ones, Macintosh, MS-DOS, and this UTF-8, but we want the plain old comma delimited version or file extension here. And let's just add a number 2 to the end, and let's click save and head on back to the console. From the console, let's click on this icon here to launch a Cloud Shell terminal session, and let's wait for it to load. To help us out, we're going to need to install a program that's named DOS to Unix by typing, of course, this command here. And then once that's installed, when we are ready to execute the script, it's going to ensure that it can properly be read so that we don't have any problems. Next up, we're actually going to need to download that script that we're going to use here. So again, in your course notes, go ahead and type this command. And then to ensure that this has the appropriate permissions it needs to execute, let's go ahead and do a chmod + and X to allow it to execute. And then let's go ahead and give that shell script permissions to execute here. And before we get ready to run our command, let's go ahead and upload that file by clicking in Actions and, of course, upload a file. Let's go ahead and select that file, which again ended in the number 2, and we'll hit upload here. While that's loading, let's go ahead and open the IAM service in a new tab and let that load. But to ensure that this file was successfully loaded, let's do a quick ls to list the contents of the files that are in this directory. And again, this is our current present working directory. And if we do a ls-ltr, we'll get a little bit more information about the contents here. But as we can see, we have our shell script, and of course we have that CSV file, the spreadsheet, which is going to be read. Before we run this, let's do a cat on that script to take a quick peek behind. Again, we can see these are the contents here. The cat command allows us to do a quick read, which it's good to do for a short file. But the hash marks, as we can see here, these are just comments. And as we can see, the purpose of this script is to automate the creation of users in AWS from a spreadsheet. how to use it. This is going to be the command that's up next. And then we need to, of course, apply the file name that needs to be read. In the columns, this again are notes from the author telling us that user, group, and password are the required column headers in the spreadsheet. And the reason being is because, as you can see here, this script will do a while loop to read the contents of the file one row at a time. And it's going to create a user, and then it's going to ensure that the password reset is required for it. And of course, set the password that's read in from the file. And then it's going to tie that user to the group name. So all of those rows, all of those specific attributes, aka the columns for each row, that's what this is taking care of. And so this is all for one row. And then of course, since it's a loop, it'll read in the second row. And that's pretty much what this will do. And like we said, 500 or 1,000 users, this is going to help automate that process and make it so quick. So let's go ahead and clear the screen. And next up, again, it's pretty much time to execute that. But before we do, let's go ahead and click on users here so that we can see how the users are created. Again, I started out with 4 here, so I expect 54 once the process is done. You may have a different number of users if you've been getting familiar with the environment. But what we need to do now is just go ahead and type that execute command. I'm going to start a clock here and then pause the video so you don't need to sit here and watch how long it takes. But we'll see what the clock is once it's done. And let's paste this, and then I'm going to start that timer right now. So way under 5 minutes and just a little bit over 2 minutes to create 50 users. So again, imagine if we had to do this manually. Imagine that with 1,000 users. But as we can see, 54 users created, associated or tied to the correct group here. Wow, that's the power again of coming up with solutions that help make life a little bit easier, not just for ourselves, but for our team members and of course customers or clients. So this again has met the first requirement for Network Your Future Incorporated. And in the next video, we're going to do part 2 of this solution and ensure that these accounts are secured properly. And we're going to talk about that in just a few moments. So great work here, but to finish it up, I'll see you in the next video. So now that we've successfully met the first customer requirement, which was to create 50 user accounts for all members of the organization's tech team, and not only that, but to also come up with a script that could help make the user account creation process that much easier for their team. Now we have a second requirement, which incorporates AWS and the industry's security best practices. The customer is requesting a security policy that requires all passwords to be a minimum of 16 characters and include at least one number and one special character. To accomplish this, let's go ahead and get signed into the AWS console. Once signed into the console, navigate to the IAM dashboard. From there, let's go ahead and click on Account Settings. By default, AWS has a password policy that enforces a minimum password length of 8 characters, but that can be changed by clicking on the Change button right here. Of course, the customer wants their minimum length to be 16 characters, so go ahead and double click in the box and type 16. Additionally, they want their passwords for their users to contain at least one number and a special character. So go ahead and place a check mark in both of these boxes. All 3 of these different settings that we just changed together meet the requirements for the customer's second conditions. But they also want us to take a look at any place that we can improve their security posture. And so while we're here in this section, why don't we go ahead and check the box for Enable Password Expiration. The default setting is to enforce all users to change their password every 90 days. Now, this isn't a bad interval, but there are industries such as the defense, government, and some financial institutions that have a more stringent policy, and sometimes they require their users to change their password every 15 or 30 days. But for now, 90 days helps to make their security posture a little bit more robust. Last but not least, let's go ahead and check this box here to allow users to change their own password. If you recall, when we were reviewing the script, there's a line in there that once the users are created, it forces them to change their password on their first sign in. So by checking this box, we can take care of that and give them that permission. So let's go ahead and save these changes. All right, now you can see that this does not say 8 characters. And additionally, we see our other changes here. So any administrator that comes into this IAM section of this account can get a big summary on what the settings already are. Let's click on dashboard one more time. And I'm going to copy this sign-in URL right here. Now let's click on users. Your usernames will be different than the ones that I have here, but let's just select one. Let's see, Chuck Horace. I'll pick Chuck Horace, and I'm actually going to sign in as Chuck Horace. Again, has no activity, so haven't logged in with this account. And I'm going to use a different browser so that I can stay logged in here. So let's go ahead and paste that URL here. And that was Chuck Horace. And again, that password from part 1 is right here. And so let's get signed in. And there you go. We are required to change our password from the script, and this user, as well as the other 49, have authorization to do that. So let's type in that password that's currently there, and let's just add a 1 behind it. Let's get logged in. And as you can see, we're getting right into the console with just a password. In a moment, we're going to add another security enhancement. But let's first take a look here. Chuck is assigned to the network admin group. So VPC, Virtual Private Cloud, is a section that this user account, as well as any other that's a part of this group, should have access to. So let's go to route table. All right, there we go. So we can see the default route table that's created here. Again, there's a default VPC as well. So things look good here. So let's see if a network admin can go to, let's say RDS. So if we try to create a database, users with a network admin are not able to do that, as they don't have enough authorization to do so. So let's go to one last spot. Again, we're just spot checking. We got 4 groups. This is the network admin group to see what they should and shouldn't be able to get to. And they're not able to view users, groups, or policies underneath the IAM section as well. One thing to key on as well, we don't see any MFA button here, but let's go ahead and head back over to the login that we have here. For our root account, we saw that we needed to add MFA to be able to sign in. So not only do we need to have our password, but we also need to have the token, the 6-digit passphrase that continually changes in Google Authenticator. 2 different mechanisms to get logged in. And so that's an additional security feature, because if ever our account was compromised or someone gains access to the password, without that additional factor, that MFA code, they still would not be able to gain access to our account. And so let's go ahead and see how we can do that. To do that, let's head on down to policy, and we're going to actually create a custom policy here. Let's click on create policy. And we're going to actually input this using the JavaScript object notation, or JSON. So let's go ahead and click on that second tab here. You'll find this code here in the notes or the description section, but go ahead and paste that here. And as you can see here, this is just allowing all of the users to be able to add their own MFA device, to create it, and to basically manage that. So let's click next. We'll skip over the tags, but we do need to give it a name. Let's name this policy enforce MFA. And then let's click on create policy. And we can see not only by the status here that that policy has been created, but it's also listed here as a customer managed policy. Let's go ahead and click on that, because now we need to assign it to our 4 groups so that subsequently all the users that are part of those groups can have this authorization. So let's click on policy usage, attach. Let's scroll down. And for each of these groups, let's go ahead and place a check in the box there. And let's go ahead and attach the policy. All right, so we now see that the enforce MFA policy that we just created is assigned to all 4 of the groups that we have. And so if we bring this back here, let's see if we need to log in or log out. So we now have an add MFA button here for Chuck Horse. And before we do anything there, let's take a look. We saw just a few minutes ago that a member of the network admin group has access to the VPC. We saw the default route table and we saw the VPCs, but what's happening here? If we click back on route tables, we get a message that says we're not authorized to perform this authorization. Therein lies the power of IAM and those policies. By enforcing all users to have MFA, yes, they can log into AWS, but even with the permissions for their respective group, they're not able to access any of those resources or services that they're privy to until they add their MFA device. Pretty cool, huh? So again, let's go ahead and head on back to IAM. And then once we're here, we're going to click on add MFA. And just like we did when we established our AWS account and that root user, we should still have our Google Authenticator software on our phone. So let's go ahead and assign MFA device. We can name it anything. I'll just put MFA. We'll hit continue. And now again, I'll hit show QR code, and with Google Authenticator, go ahead and pull that up on your phone and hit that plus sign and scan a QR code. Now it's going to be added to your application, and we need to type in 2 successive codes. So this is the first one that pops up for me. Of course, that code changes every few seconds. I think it's about every 15 seconds or so. And the second one is coming up right now. And then once you have 2 codes consecutively, hit assign MFA and bingo. Now we can hit close. And let's see if we can go back to VPC without signing out. So there we go. Anytime we do anything that's kind of an administrative type privilege, we do need to log out and back in. So let's go ahead and sign out. And it's a good check as well, just to make sure. Again, let's go ahead and if you got that URL handy, makes it a little bit easier. So this was Chuck Horse. And again, for me, the original password from part 1 with the number 1 at the end. All right, MFA code. We just added that. So This will be our first time logging in with that. And there we go. Success. So now let's go ahead and check to see if we now have gained access to the resources and permissions that we know a user with this group should have. And there we go. Once again, we're able to see different parts of VPC. We can see the subnets. Again, all of these are defaults, and we'll be exploring this in an upcoming module, the default VPC that's created. And of course, no internet gateways, but like we said, so we've now successfully met the requirements for both conditions that our customer gave to us. How amazing is that? Definitely proud of you, superstar. You're on your way. But again, that third ask was to kind of do a debrief and to just give them information on really how things went, what we saw, what we did, and what we learned. So the last thing that I want to ask is to use the template that's in the description as well. And it doesn't have to be elaborate, but just put your thinking cap on. And even if it's just a paragraph, just summarize what we did in this course project. That's the ask here, is to just summarize what you just did. And that goes a long way in helping ensure that you retain that knowledge and are able to begin to speak like the cloud and tech professional that you are. But again, super proud of you. Amazing, amazing work here. And I'll see you in the next video. All right, superstar. Very quick. At the end of each of our modules that has a project, we're going to show you how to quickly clean up the environment so that we can ensure that there's no charges and also that you stay organized and efficient. So here we, of course, created a policy, but we will leave that policy there. But of course, with that script, for those 50 users, let's go ahead and click on users. Again, from the console underneath the IAM service. And what we want to do here, I have 3 pages of users once this screen finishes refreshing. And go ahead and sort by the password age. Even if you were playing around with one or a few of those users, most of them were not selected. So let's go ahead and select this box. Let's scroll down to make sure that our user account that we created for ourselves isn't checked. And let's go ahead and select delete. It's going to ask us to type the word delete, so no worries there. Now we're down to 2 pages. Once that's done, and again, let's do the same thing. Checkbox here. Scroll down, make sure that the personal account is not there. Let's hit delete, type delete, and hit delete. And now we should be down to 1 page. Again, if you want to leave any of these users to, play around with or to do anything with, no problem there. It won't cost any money, but this part here is just to get our environment a little bit more organized for the upcoming modules. So let me uncheck my account there, and then I will delete the remaining ones. And once you hit delete one more time, again, at least for myself, there's only 1 user left. Again, the groups, no worries about those. And the policy, the one that we created there, doesn't look too bad. So again, great job at cleaning up the environment, but just make sure that you do that. And in our upcoming modules, we'll do the same. But again, see you in the next video. Welcome to Module 3, where things really start to connect, both literally and figuratively. That's because in this module, we're going to learn all about the virtual private cloud, or VPC infrastructure inside of AWS. The VPC service is a major component of the networking and content delivery services, one of AWS's core services. We will focus on the essential elements needed to plan and build a VPC, which is needed to provide connectivity to and from the internet. Over the course of this module, we will be introducing AWS's virtual private cloud service, along with learning information about where AWS's infrastructure is located around the globe. Then we will hop into the console and create our very first VPC. Subnets, route tables, and network gateways are all essential elements for connecting resources inside of AWS. So understanding the purpose and use of each is essential. Each one of these elements builds upon one another, and just like the VPC, we will hop into the console and configure each as well. Once we have all these elements properly configured, we will have a VPC that contains all the essentials to provide connectivity for virtual machines or any other resource that may be deployed inside of the VPC. And our hands-on project will allow us to take what we learn in this module to the next level, as we will use a tool for automating the entire setup of a VPC infrastructure with just a few commands. So if you're ready to connect the dots, let's get started. Amazon states that a virtual private cloud enables you to launch AWS resources into a virtual network that you've defined. This virtual network closely resembles a traditional network that you'd operate in your own data center, with the benefits of using the scalable infrastructure of AWS. So what does this really mean? Well, first off, you have to understand that although the term cloud is tossed around very loosely, these networks and AWS resources actually reside on physical hardware and equipment that AWS has spread all around the globe. A VPC represents a logical piece of that network that's your very own. Think of this as if AWS owned billions of houses around the globe, and they gave you your very own house that only you could decorate or paint the way you want it to. This takes us to our very next point, which is AWS regions. AWS has the concept of a region, which is a physical location around the world where data centers are clustered. This is the broadest geographic category that defines the physical location of their data centers. Currently, there are 30 regions dispersed worldwide across North America, South America, Europe, China, Africa, Asia Pacific, and the Middle East. And there's plans to bring on 5 more AWS regions in the near future. All regions are isolated and independent of one another, and they meet the highest levels of security, compliance, and data protection. When choosing a region for your VPCs, think of where most of the traffic will occur. So if you're in eastern part of North America and most of your consumers for the foreseeable future will request resources from that part of the world, then typically you would choose a region on the East Coast, such as Northern Virginia or Ohio, but essentially in the US East region as opposed to one that's in Asia. But within these regions, an availability zone is one or more discrete data centers that provide redundant power, networking, and connectivity in an AWS region. All availability zones are interconnected with high bandwidth, low latency networking over fully redundant, dedicated fiber that provide this high throughput and low latency. Traffic that travels between AZs is encrypted to protect the data, and AZs are physically separated by a meaningful distance, oftentimes more than 100 kilometers, to ensure that in the event of a catastrophic weather event or other emergency, that if multiple availability zones are used, customers would not incur an outage. We're gonna hop into the console here very shortly, and we're gonna create our very own VPC. All VPCs are created and exist in one and only one AWS region, but a customer can create multiple VPCs within an AWS account. Each Amazon account comes with a default VPC that's pre-configured so that you can start working immediately. But to create a VPC, there are 2 requirements. First off, every VPC must have a name. The VPC that we're going to create here is going to be named NYF Production VPC. Second, you must specify the CIDR block of the VPC, and this provides the IP ranges for resources within that VPC. We're going to configure ours with 10.200.0.0/24. So now it's time to create our very own VPC. So from the console and home, let's first pause and take a look. Let's make sure that we're in the Northern Virginia region. Again, that's going to be US East 1. And as you recall, When we were configuring different settings within the IAM service, we actually were not in a specific region. And the reason for that is because IAM is a global service. So the users and groups and the different policies there actually touch every region. But for the VPC service, we actually have to pick our specific region. And for the remainder of this bootcamp, we're going to be configuring different services within the Northern Virginia region. So make sure you click on US East 1. Okay, once you've done that, go ahead and search for VPC. And then let's go ahead and click on that. The VPC service is pretty expansive. As you can see here along the left side menu, if you scroll down, these are all the different services that are available to you. But again, we're going to start with just taking a look at the VPC. As we discussed, there is one default VPC that is created within every account. But to create our own, let's go ahead and click on Create VPC. Let's give it a name. NYF Production is the name that we said we would use. And for that CIDR block, 10.200.0.0/24. Again, leave the tenancy default and automatically a name tag is applied. And these are the only two requirements. And once we click Create VPC, you'll see here that that was successfully created. And here you just have a summary of the details that are here. So if you go ahead and click back on your VPCs, then again, we'll see that default VPC as well as our own. For the time being, we will go ahead and keep the default VPC there. As you can see in this column here, it is there. To delete that VPC, you would have to make another VPC the default VPC before you could do that option. But again, we'll leave this one for now. But congratulations on creating your very first VPC inside of AWS. A subnet is a key component in a VPC. If the CIDR of the VPC represents a home, then a subnet represents a room within that home. It's a segment or slice of the VPC, and it allows administrators a method to logically group different resources within that VPC. So expanding upon our topology here, which we will be configuring in the console in just a short while, we see that the VPC has a CIDR of 10.200.0.0/24, which means there are 256 IP addresses that range from 10.200.0.0 to 10.200.0.255. By taking advantage of subnets, we can carve those 256 addresses up into logical groupings that look something like this. For the public 1A subnet, we will use a CIDR of 10.200.0.0/26. For the public 1B subnet, we will use a CIDR of 10.200.0.64/26. For the private 1A subnet, we will use a CIDR of 10.200.0.128/26. And for the private 1B subnet, we will use a CIDR of, you guessed it, 10.200.0.192/26. So why did I choose a /26? Well, for CIDR notation, a /32 network mask represents a single IP address, and it's often referred to as a host route. A /31 covers 2 IP addresses. A /30 covers 4. /29 covers 8. /28 16. /27 32, and a /26 covers 64 IP addresses. So each of these subnets has 64 IP addresses, and all 4 subnets together would utilize all 256 IP addresses of the VPC. So depending on the future needs of the organization, this plan will not allow for future growth in this VPC, as the CIDR of a VPC cannot be changed once it is created. But this design is good for what we are trying to accomplish here. But before we hop into the console to configure these subnets, there's one thing to note, which is for every subnet, there are 5 IP addresses that are reserved and cannot be allocated to resources within the subnet. Let's take the public 1A subnet, for example. The first IP from the subnet, which is 10.200.0.0, represents the network address. The second of 10.200.0.1 is reserved by AWS for the VPC router, which is often the gateway of the subnet. The third, 10.200.0.2, is reserved by AWS and is the IP address of the DNS server for the subnet. 10.200.0.3, the fourth address, is reserved by AWS for future use. And the last IP address of this subnet, 10.200.0.63, is the network broadcast address. And although AWS currently does not support broadcast addresses in a VPC, they still reserve this IP address. But as you may already start to be thinking, proper planning plays an essential part of any cloud professional's journey, and building out the components of a VPC properly is typically where it all begins. This is where you can set an organization up for success or for failure without proper planning. But of course, we will always choose the first. But just remember, a subnet is just one component of a VPC, but it is a very important one. So now it's time to create those 4 subnets that we just discussed. So from the AWS console, if you're in the VPC service, then you should see the VPC that we just created in the last lesson. If for some reason you know you've created and it's not populating, chances are you may be in the wrong region. Make sure that you're in the Northern Virginia region, which is US East 1. Now go ahead and click on Subnets. And just like we saw earlier that there was a default VPC automatically created, the same is true for the subnets. Again, this is to help you get off and running and just to create an environment if you're in a rush. But to create our very own subnets, click on Create Subnet. Let's select our VPC, which is named NYF Production. All right, now we've already planned what the CIDR is, as well as the subnet name and the availability zone. Those 3 pieces of information are required for each subnet that you're going to create. So let's go ahead and get started with Web 1A. And again, that was in availability zone US East 1A. Let's now type in that CIDR 10.200.0.0/26. Let's add a new subnet. And this will be Web 1B. This is one of the screens where you can create all the elements on one screen without doing it one at a time. And again, US East 1B, 10.200.0.64/26. And then we'll hit add new subnet for our third one. This will be DB1A, AZ1A, 10.200.0.128/26. And our final subnet, DB1B, US East 1B, 10.200.0.192/26. And once you have all 4 subnets created, again, we'll do a final check. Make sure we have 1B1A, 1B1A, and of course the name is proper, and the CIDRs. Then you can go ahead and hit Create Subnet once you're happy with all the settings. And that's all that's required to create the subnets. But if we take a look here, as we discussed in the overview, there are 5 IP addresses from each subnet that are reserved for AWS. So instead of seeing 64 here, that's why you only see 59 for each subnet. But again, great job, superstar. Things are finally starting to come together, and we've got a few more components to add. So I'll see you in the next video. So now that we have a VPC, which represents our very own part of AWS, where we can build and deploy resources, and we've also got our subnets, both public and private, that are balanced across 2 different availability zones, The next component that we need to know about are the different network gateways that are available. And we will primarily focus on the two that we absolutely must understand their use case for. But we'll discuss those in just a few seconds. But you may have noticed in the Subnets Overview lesson that I skipped right over explaining the difference between a public and a private subnet. The network gateways will help make it easier to explain. So let's just begin understanding what an internet gateway provides. An internet gateway is a service that allows for internet traffic to actually enter into a VPC. Otherwise, a VPC is completely segmented off. An internet gateway is a logical connection between an AWS VPC and the internet, meaning it's not a physical device. Each VPC can only have one internet gateway, and you'll see in the console that after you create an internet gateway, you must attach it to the VPC for it to actively forward traffic. If a VPC doesn't have an internet gateway, then the resources cannot be accessed from the internet. But not all network resources need to be accessible from the internet. But for those that are, they must have a public IP address, which is known in AWS as an elastic IP address or an EIP, to be able to do so. So to sum it up, public subnets are able to forward traffic directly to an internet gateway to reach the internet. But what about private subnets? Private subnets do not have elastic IP addresses. They have private IP addresses that are not routable on the internet. So when they need to communicate with the internet, there needs to be a device that can translate this private IP address into a public one. This is where a NAT gateway shines perfectly for our use case. A NAT gateway enables instances in a private subnet to connect to the internet, but they prevent the internet from initiating a connection to those devices. To perform this functionality, NAT gateways map all the private IP addresses assigned to the instances in the subnet to a single public IPv4 address, which we just learned is called an elastic IP address. So in summary, a device capable of performing NAT is needed for devices in a private subnet to communicate on the internet. Although there are many third-party appliances capable of performing this action, in this bootcamp, we will use the AWS NAT gateway, which is managed by AWS, to simplify those functions that it performs. Before we create our internet and NAT gateway, let's again double check and ensure that we're in the correct region, which is US East 1, which is in Northern Virginia. If all looks well and we see our VPC, then simply click on Internet Gateways. And just as we saw with VPC and subnets, AWS does create a default internet gateway for us. Its state is currently attached, and it's attached to the default gateway. You can validate this by going to Actions, View Details. In the VPC ID, if we were to open that in a new tab, this would confirm that the internet gateway is attached to this default VPC. But now that we have all of that checked, let's go ahead and head on back to Internet Gateway. Click on Create Internet Gateway. And here we have to give our internet gateway a name. NYF Production IGW is what we will call it. Once that's done, click on Create Internet Gateway. And now we have our internet gateway created, but as you can see, the current state is detached. So while you're here, click on Actions, Attach to VPC, and let's go ahead and select our NYF Production VPC and attach Internet Gateway. Now that the Internet Gateway is attached, we see that the VPC ID is the one that we need, then we're all set with creating our Internet Gateway. To create our NAT gateway, let's go ahead and click on NAT Gateways. And we're actually going to create two NAT gateways, one for each availability zone. Again, this is to ensure that there is high availability in the unlikely event that one of AWS's availability zone is affected. We can ensure that traffic still continues to pass across the other availability zone. But let's create the first one by clicking Create NAT Gateway. Here we'll give it a name, NYF Production AZ1, We'll choose our subnet, and again, remember from our drawing that this needs to be in the public subnet. So for availability zone 1, let's click public 1A. This will be a public NAT gateway, and we have to allocate an elastic IP. Now let's click Create NAT Gateway, and the state is pending. But while that one's spinning up, let's go ahead and create our second one. So we'll click back on this X here, and up top, click back on NAT Gateways, create NAT Gateway. And again, for our second NAT gateway, we'll call this NYF Production AZ2. Subnet will be public 1B, and we will allocate another elastic IP. Again, this is so that when we get to the point of where we're deploying servers, for those servers to reach and communicate on the internet, we need this NAT gateway device to translate the private IP address that those resources will have into this single public elastic IP address. Click Create NAT Gateway. And now let's see if that first one's done. It's pending just like the second one, but let's go ahead and wait a few seconds. So now we can see that we have both NAT gateways created. Both of them have an elastic IP address along with a local private IP address. And if we go ahead and highlight the one that's in availability zone 1, we see that it's placed in the proper subnet public 1A. And likewise for the one that's in availability zone 2, it's in public 1B subnet. So now we have a design that provides high availability in the event of a failure. And likewise for the internet gateway, it is in a state that's currently attached to our VPC. So great job creating that internet gateway in both NAT gateways. We've got just one more component before our VPC infrastructure is fully ready. So now it's time to talk about the last main component needed from within our VPC infrastructure, and that is route tables. Route tables are configured to control where traffic is directed into and out of a VPC, and sometimes even within a VPC. Think of the route table as the brains of the operation. A subnet can only be associated with a single route table. However, a route table can have multiple subnets associated with it. By default, a route table comes already configured with a local route, which matches the CIDR of the VPC. This means that by default, traffic within a VPC knows how to forward traffic to other subnets in the VPC. The two pieces of information that can be configured in every route table are the destination and the target. The destination is the CIDR that matches the destination for the specific route, while the target is where traffic destined to the destination should be forwarded to. So for our public subnets, we need to create a route table that forwards all traffic to the internet gateway. Likewise, for our private subnets, we need to create route tables that forward all traffic to the NAT gateway. And because we configured two NAT gateways, we will need to create two separate route tables. And each route table will target a NAT gateway from each availability zone. So now it's time to create our route tables. But before we do that, let's take a look at the default route tables. So again, ensure that you're in the Northern Virginia region and then simply click on Route Tables. As we can see here, there is a default route table that AWS automatically creates with each VPC, and it sets the route table to be the main route table for that VPC. If we select the one that corresponds with NYF Production VPC, we can see that no subnets are associated with this route table, and by default, the only route that's known is the local route that matches the CIDR of the VPC. Now let's go ahead and create our route tables. And to do so, click on Create Route Table. And the first one that we'll create is going to be our public route table. So let's give it a name, public-RT, and then select the VPC of NYF Production. And that's it. Simply hit Create Route Table. Now, while we're here on the public route table, let's go ahead and associate the two public subnets with this route table. So click on the Subnet Associations tab, edit Subnet Associations, and place a check in the box beside public 1A and public 1B, and then hit Save Associations. The last thing that we need to do is to create the route for this route table, because again, by default, the only route that's known is the local route. So let's hit Edit Routes, add a route, and the route that we need is going to be a destination for all IP addresses, because any resource that resides in the public subnet that needs to reach the internet needs to match this route. So if we click in the box, we see that 0.0.0.0/0, which is often referred to as quad 0, is the one that we want. This will match every IP address, and we need it to target the internet gateway. So click on Internet Gateway, and we'll see our internet gateway that's attached to this VPC. So click on it and then save those changes. Once you've done that, then the route table is fully configured for the public subnets. And just a quick recap, we've associated explicitly both public 1A and public 1B subnets, and we've configured a route for all IP addresses to target the internet gateway. Now it's time to tackle our private route tables. Again, remember, because we have two NAT gateways, we need to create a separate route table for each. So again, hit Create Route Table. We'll name our first private RT-1A. We'll select the NYF Production VPC, and we'll create this route table. Underneath the Subnet Associations tab, let's click Edit Subnet Associations and select Private 1A, just this one, to associate it with the route table that corresponds to Availability Zone 1A. Now let's hit Save Associations. And again, remember from the public route table that the last thing that's needed is to configure the route. So hit Edit Routes, add a route. And for private resources to access the internet in the outbound direction, we again need to add a quad 0 destination. So go ahead and either type that or select it from the box. And our target will be a NAT gateway, and we'll pick the one that's Availability Zone 1. Save that change. And that's it for our very first private route table for Availability Zone 1. Now let's do the same for 1B. So come back into Route Tables, create route table. We'll name this one Private RT-1B. The VPC will be NYF Production. Create route table. Subnets Associations, edit Subnet Associations. And again, as you can see here, the only one that's left that doesn't have a route table associated is gonna be Private 1B. So guilty by process of elimination. We'll hit Save Associations. And now that we're on the Routes tab, the last thing to do is edit routes, add a route. And just like 1A, we need to match all IP addresses. So we'll enter quad 0. And the target now is still gonna be a NAT gateway, but the one that resides in Availability Zone 2, or 1B to be more specific. And once you've selected that one, save those changes. And we'll go back to route tables. And again, look at here. We now have created 3 route tables that covers all 4 subnets. And so in this module, we've fully configured the essential elements that's needed for VPC. Great job at layering each of those components on top of each other. And so now it's time to take all that we've learned into our hands-on project. Network Your Future Incorporated was very excited with the work we did on the IAM project. So they've asked us to come and be a consultant with them on a requirement that they have. The ask is to automate the creation of the VPC infrastructure, as their staff is familiar with manually creating the VPC services within AWS, but they have a mandate from the government to automate this process. The deadline is fast approaching, and they've only given us until tomorrow by close of business to come up with a solution for them. Now, taking a look at these requirements, we should be very familiar with the components. A single VPC with 4 subnets, one public and one private, and a pair of those, one in each availability zone. The 3 route tables, one public, where both public subnets will be associated with that, and 2 private route tables, one per availability zone, to go with the 2 NAT gateways and a single internet gateway. Just like their staff, we have experience manually configuring this inside of the AWS console, but this solution will tax our brains, as we're going to use an infrastructure as a code solution to rapidly deploy and create these resources inside of AWS. And not just that, but we'll also be able to tear down and destroy that via code. That deadline's fast approaching, so let's get to it. So we're already familiar with what goes into creating a VPC infrastructure in AWS. We know that we need a name and a CIDR block for our VPC, and we know what's needed to properly route traffic for both public and private subnets. So now, to meet our clients' requirements and take our game to the next level, we need to come up with a solution to automate that entire process. AWS offers an infrastructure as a code solution known as CloudFormation. Using templates that are formatted as text files, which often use either JSON or YAML format, you're able to start creating the blueprint for deploying AWS resources as code. And while not a bad option, if the client ever decided to move to another cloud provider, they would have to find another solution, since CloudFormation is written strictly for AWS. But on the other hand, HashiCorp's Terraform is an open source tool that allows us to automate infrastructure on any cloud provider's platform. The particulars of Terraform deserves a course of its own, but we will use this tool as our solution to the client, and I've already written the code that will meet their requirements. So let's take a quick peek before we demonstrate how easy it is to create and destroy a VPC infrastructure with this tool. We're going to use the Cloud Shell to download Terraform to simplify the execution of the code, but I'm going to actually use a visual editor program called Visual Studio Code to provide a quick overview. There are numerous ways to write code for the same solution, and it's possible to put all the code into a single file, but we've elected to break our code out into individual files that pertain to the specific functions of creating a VPC infrastructure. So let me quickly provide a high-level overview of what our code will be doing. Terraform files have an extension of .tf, and our main Terraform file here simply specifies the region that our code is going to deploy in, which is the US East 1. But of particular note also is this provider AWS. Currently, Terraform supports over 130 providers other than AWS. But this is where it knows how to go down and pull the appropriate plugins and modules for each of those providers. So if our client ever decided, for instance, to move to Azure, they'd simply need to change this provider to Azure, and they'd be able to use all of this code. So heading down to the VPC file, which we're very familiar with, this resource, which is the AWS VPC, has a local identifier that we've chosen to give it VPC. We could have chosen any name such as ice cream or ABC123, but what this local identifier does is if we need to reference this anywhere in the code, it's easier to make this a name that you definitely can easily know what its use is. For the CIDR block, we are using a variable named VPC CIDR. So if we go to the variables file, here we see 5 different variables that have no value. The values are actually stored in the only file that ends in .tf vars, and this is where the values for the variables are contained. And so this is where we see for the VPC CIDR variable, the specific value of 10.100.0.0/16. So when we run this Terraform code here in just a few minutes, we're going to see that this is the CIDR that it's going to create for the VPC. And again, we're using the tag to apply the name right here. But going back to that TFRs, we see the other 4 are, of course, for the 4 different subnets. And you probably could have guessed that by taking a look at this. So let's go ahead and head on over to the subnets. Here on the subnets, this again is the resource, but instead of AWS VPC, it's AWS subnet. And of course, a different local identifier, pub sub 1 and pub sub 2, again, sub for subnet. So these are our 2 subnet resources that are going to be created. And again, the CIDR block, this is that variable with the name that we just saw, and the VPC ID. This is the specific attribute from that AWS VPC resource and the VPC, that local identifier. Now for the availability zones, we see here that the availability zones data source, which allows access to the list of AWS availability zones so that our code can access the specific region within the AWS account to pull down the specific AZs for that region, because counter to popular belief, each of the regions are not, identified as 1A, 1B, 1C, 1D. Some of the regions, their availability zones are like 2A or 2G. So this is how our code knows to get the right one. And for the first public subnet, we see that it's going to use an index value of 0, which is actually the first one of 1A in the console. And likewise, for the second public subnet, the index is 1, which corresponds to the second AZ in US East 1, which is 1B. Now, this method of counting starting at 0 for the first value, it's referred to as counting canonically. So if we come down just a little bit, the same type of code is used for the private subnets. Next up, we're going to take a look at the gateways. And here for our gateways, we see that we start off with the resource of EIP, or those elastic IP addresses that the NAT gateways need. So we're reserving those. And because we're going to need 2 NAT gateways, we need to give them uniquely identified names. One is NAT1, one is NAT2. And down here, when we're creating those NAT gateways, again, this is where we're referencing the first elastic IP for NAT1 to basically make the proper association to the first NAT gateway. And likewise, for the second NAT gateway, we're using the second elastic IP that we made up there. And then this depends on line. There's certain things that need to happen in certain order. If there was something in the code while it was building it out that needed to wait, there may be timeouts and retries. But if you already know of those dependencies, using this depends on this NAT gateway building it, it'll wait until the internet gateway is built. So that's what that's doing right there. And of course, this resource is going to deploy the internet gateway. Last but not least, of course, my favorite part is the route tables. So for our public route table, we see that the destination is all zeros, which again matches all traffic. And the target is going to be the internet gateway. And down here, these 2 blocks of code are going to tie the 2 public subnets or associate them with that route table. And again, using that naming convention that we just saw, of course, the resource, the local identifier, and then it needs to get that specific ID to tie everything together. Now, for the private route tables, as we saw in the last lesson while we were building them out, similar to the public route tables, the destination is still going to match all traffic, the quad 0. But instead of being routing it or targeting it to the internet gateway, these, of course, will be targeting the NAT gateway. And so for the first private route table, it's going to target NAT gateway 1, which is in AZ1A. And for the second private subnet, it's going to target the second NAT gateway that's in AZ1B. And when we deploy it and create it, this will be the last thing or resource that gets deployed. We're going to check to make sure these IDs are different. And likewise, the final thing is associating each of those subnets to the proper route table. And it's basically route table 1 for the private is going to be tied to subnet private 1. And of course, same for subnet private 2, private subnet 2, I should say, and the second private route table. So that again is pretty much a high level overview of our code. And it's definitely a lot to take in. And like I said earlier, learning and teaching Terraform truly deserves a course of its own, but I wouldn't have felt right not going over the code for our solution. So I definitely hope you found value in this, and it's almost time to basically demonstrate our solution. So for that, let's go ahead and head on over to the AWS console. So from our AWS console session, we need to, of course, activate our Cloud Shell session. So let's click on this icon here and let's go ahead and let that load, because we're going to need to download, of course, our Terraform. So let me, while that's loading, get those lines of code. You can find these in your resources. So I'm going to paste these in right here. Those are the lines there. And that again is basically installing Terraform here in our Cloud Shell in our home directory. These lines are kind of making a symbiotic link so that if we got out of a session, came back in, it makes sure that this bin directory, that all of our variables for this environment are consistent and we don't lose anything. And we're specifying the specific version of 1.2.5 here, which we know works with our code. So again, likewise, let's go ahead and download that zip file, which basically when we unzip it, there we go. Sorry. All right, so there we go. So now to unzip that, just simply type unzip and then the file name. We'll tab that to complete. And now if we do a ls, we see both here. Let's do a little bit of cleanup. We'll do a rm to remove that zip file. Let's do a .zip. And now we just see our directory, which we need to go into. So cd to change into that directory. And then there we go. And if we do a ls, these are, again, those TF files. And of course, that single TF vars that we just went over or saw in Visual Studio Code. So this is our code, and it's now time to basically let the drum roll and do the magic. But before we do that, I'd like to ask, or I'll do it on my screen, and if you're following along, hit services or click on services, right click on VPC and open this in a new tab. We actually want to see the elements or the components being built right as we're running our code. So let's go ahead and do that. And here we go. So let's wait for our VPC. We're going to do this live, no skipping ahead, no fast forwarding, no editing, no magic. Actually want to talk this through in real time along with when we do the destruction. So one thing to note here as well, let's see, but let's go ahead and clear our screen. And I did skip a command that was that copy paste issue from earlier, this TF environment use 1.2.5, and this is going to set the specific version to use there. So now we're actually ready to run our Terraform code. So let's go ahead and do a Terraform init. And this is going to initialize our environment and basically download the required plugins. And our provider, of course, is AWS. So again, online, it's going to download the trusted plugins that it needs to run the code. And as you can see, we have successfully initialized this. So now if we were to do an ls, this again is just getting a little bit ahead of the curve outside of the requirements, but we now will run a Terraform plan. And this is going to output a plan and tell us, the cloud administrator, on what it's getting ready to deploy if we were to, of course, apply these changes. You'll see in a lot of these sections, it tells us that this value will be known after the apply. And that's because there's certain things like when you create the NAT gateway, we saw that in the console when we did it here manually, it took a while to finish getting built, the state to go to kind of complete or available. So you won't know the IDs or different things until it's fully done. But just scrolling up here to take a look at everything there. So now that we have our plan, we see that 17 different resources or components are going to be run. Let me do an ls again. There we go. So we don't have our state file yet. Just showing you that we don't have that, but now it's time to run a Terraform apply. If we do a Terraform apply without the -- auto - approve, it's going to ask us, are we sure? So here again, it's going to display the same thing, and it's going to prompt us to type yes to auto approve. So now we're going to click that, and it's off to the races. It's creating. We see if we can read fast enough the VPCs first and then those elastic IPs. So if we refresh the VPC again, this is going to be live, no fast forwarding or anything like that. We see that our VPC is already created. And when we were explaining the variables files, we said to remember this is the CIDR block that we're going to use for this VPC. NAT gateways are being created. Those again will take a while. We got our route tables there, and of course the internet gateway, because we saw that the NAT gateway depend on that being created first. So if we were to go to our subnets, because when we manually created our NAT gateway, we saw that the two different parameters in the route table is the destination and the target, but we cannot pick our NAT gateway 1 and 2 as a target until they're actually fully created. So that's what we're going to be waiting on there. But we see the 4 subnets. But like I just explained for the route table, if we sort here, we see that the public route table is already done. And because the internet gateway is created, if we click on this, we see that both subnets are associated, and the destination for that is all zeros in the target of the internet gateway. So now it's really just waiting for the NAT gateways to be created. And again, as we see here, we have 2 that are pending. Again, so once those are done, we're going to basically pretty much be ready. But let's see. We'll have to wait on those. So let's refresh. So we see that our first one is available. So if we click on that, we know the second one should be right behind it. So it's probably finishing up here in just a few seconds. Let's see, 1:50. Maybe we can get this done in under 2 minutes. Might be a record. Did a test run here for these earlier. This took about 2 minutes and 36 seconds to complete. But let me refresh and see. So both NAT gateways are available. So let's see. All right, so let's go back to the route table there. And we see that we have our private 1A, and subnet association is going to be with .2. Again, destination for all will point to this NAT gateway. And like we said, this target ends in BD7. And so we should have a different identifier for our second NAT gateway. And this one ends in A39. So again, everything is looking good here. We're just waiting on the code to tell us that it's done creating all 17 resources. And I expect that to be here very, very soon. But let's see, subnets, VPC, route table, internet gateway. And that should be about it. Let's see, let's go back here. A and B, NAT gateway. All right. Minute 40. But yeah, this is definitely pretty amazing to be able to learn the logic of the code. And as long as you start to understand the elements or the attributes that go into each of the different components, it makes it a little bit easier to understand. So that's why sometimes going the long route first and learning and understanding how to create, for example, the VPC infrastructure entirely through the console manually, almost a crawl before you walk type of state. It should make reading and understanding the Terraform code just a little bit easier than if you came into a little bit blind. So that's all that is. But not sure what's happening here in the code. We have everything created. So let's see what it's trying to do. It's finished up there. I don't know if it was tightening up something in the background. May have been 2 minutes and 40 seconds. But again, it looks like all 17 of those were created. And you saw me earlier looking for this state file, but making sure that it wasn't listed yet. So now when we do an ls back in our code, we do see that we have this terraform.tf state. And the amazing thing about Terraform as a code is not only does it keep track of the resources that are created, but it also keeps track of those that are destroyed. And so it has kind of a versioning component so that if we were to come in here, because there are flags where we can put in our code to say, destroy just one NAT gateway. And so if it destroyed that and all of its components, the next time we ran Terraform, it wouldn't deploy all 17 resources. It would look at this state file and compare it to the desired state and say, hey, everything for NAT gateway 1 is still there. So I just need to rebuild the NAT 2 and its components. But if we do a CAT, and we do Terraform TF state, we're going to now basically be able to see that this file is showing the resources that it created and it's managing right now. And if you were to go in here, it's basically all of the attributes that are possible for each of those resources. So pretty cool there, but it's basically amazing to be able to do that. So now it's really time to destroy this infrastructure. And so again, we're going to do the opposite, but let's do Terraform destroy. And then we're going to do this time, the -- auto approve. And we're going to destroy these resources programmatically or via code. So this is that second part of the requirement. We, of course, just demonstrated that we created the entire VPC infrastructure that's needed per their requirements. And so now we're doing the second part, like we said, which is to demonstrate that we can destroy that infrastructure via code. So pretty amazing. This one, we're just going to wait for it to say finish before we do any refreshes here. But the last thing that it will destroy is going to be the VPC. Kind of backwards. It was the first thing that it created. So, that which is first shall be last. So let's see. We'll wait just a little bit more. But let's see, if I had to take a guess, these NAT gateways are, well, I don't even have to guess. We can read the description here and kind of get a guess of what's happening. It's messing with these elastic IPs. NAT gateway still destroying. Let's take a look there. So all 4 deleted. Again, 2 that we did a dry run or a test run right before this. So it's gone ahead and destroyed all 17 resources. So again, subnets are no longer here. And the internet gateway. And of course, no route table for those. And just back to 2 VPC. So again, we just demonstrated how we could, via code, maintain, deploy, manage, and of course, destroy VPC infrastructure. And just to demonstrate here, we just saw that we listed all the components of the resources, but now it's basically empty. So amazing, amazing job. Super, super proud of you. And we can see not only now not only what's possible in the cloud, but how we can continue to elevate ourselves and continue to layer different things that we're learning on one another to continue to take it to the next level. So this is just the start. Again, up in our next module, we're going to now be deploying servers so we can get familiar with actually logging into servers, running different codes, websites, and things like that. So this was the fundamentals of the networking piece. This is what's needed to basically establish the routes and to make sure that when we deploy our servers that they know how to get to the internet and basically how to receive traffic from the internet. So again, great job. Our client is going to be very happy with this as well. So continue to do great work, and there's definitely more to do. So I'll see you in the next video. So now that our VPC project is complete, it's time to clean up the environment. Because NAT gateways can incur undesired costs, let's start by first removing the routes that target each NAT gateway. We'll start off with private subnet 1A's route table. After highlighting the route table, click the Routes tab and then Edit Routes. We will then click the Remove button beside the default route. We will do the exact same thing for private 1B's route table. So now that we've removed the NAT gateways as targets from the route tables, we can go ahead and delete those NAT gateways. So let's go ahead and click on NAT gateways. Then we'll highlight the first NAT gateway. Click on Actions, delete NAT gateway, type delete, and then click on the delete button, and we're all set with deleting our first NAT gateway. After highlighting the second NAT gateway, we just need to do the exact same thing to delete the second NAT gateway. Now let's make our VPC environment a little bit more organized. Since we have created our very own VPC infrastructure, we honestly have no need for the default VPC infrastructure that came with our account. So let's highlight the default VPC, click on Actions, and delete VPC. Check the box acknowledging that we want to delete the default VPC and all of its components. And once you have, type delete default VPC in this box right here to confirm the deletion, and finally click delete. Now, as we look at the different areas, we can see all that's visible is our NYF production VPC. The last thing we want to do is to now get rid of the default route table that was created with our VPC. Notice that this route table is set as the main route table for this VPC. So let's highlight the private 1A route table and click Actions. Next, click on Set Main Route Table. Now to confirm this, type Set and then click OK. Now we are able to delete the unneeded default route table. So go ahead and highlight it, click Actions, delete route table, and from here, you know what to do. So now our environment is all set and ready for our next module, where we will learn all about compute services. In this module, we're going to be talking all about compute services on AWS, and we'll focus primarily on the essential compute services that'll definitely make you dangerous as a cloud professional. We will begin by learning all about Elastic Compute Cloud Service, more commonly known as EC2, which enables you to leverage cloud-based virtual machines for your workloads. This is one of the foundational core services of AWS, so we will spend some time getting familiar with it. And inside of the console, we'll also gain knowledge of the various configurations and capabilities by launching our very first EC2 instances in the cloud. Pricing is always an important piece of information to be aware of, and thus, we will take a look at the various pricing models for compute services. The Amazon Marketplace has thousands of unique software products offered in their online shop in various formats, one of which is the Amazon Machine Image, or AMI. They can be used to quickly and securely deploy virtual machines in the cloud, and there's a huge variety of products to choose from. The marketplace also offers many software as a service solutions, more commonly referred to as SaaS, and we'll get a chance to explore what this is all about. We will also be introducing the various types of elastic load balancers, or ELBs. ELBs help to automatically distribute incoming application traffic across different targets that you configure. These are typically EC2 instances, so if one of them were to go down, ELBs help to ensure that traffic still gets forwarded to the remaining healthy targets. In that lesson, we'll have a lot of fun, and it'll lead up to our hands-on project where we will deploy an internet-facing application load balancer to solve a real-world problem. So if you're ready, let's get started. In this lesson, we're going to provide an overview of AWS Elastic Compute Cloud, more commonly referred to as EC2. AWS EC2 is a web service that provides compute capacity in the cloud, and it's designed to make web-scale computing easier for developers. Next, we're going to discuss the primary EC2 concepts that you need to understand before launching an EC2 instance in the cloud. First, we need to understand the various instance types. Then, the two different root device types. Next up is the Amazon machine image, which plays a huge role. And finally, the different purchase options. An EC2 instance type defines the processor, memory, and storage type that are available to any server that is launched with that instance type. One thing to note is that although the instance type is chosen upon launch, it is possible to change the instance type once an EC2 instance has been deployed. But this change will be disruptive, as you must first stop the instance, change the instance type, and then restart the instance. Additionally, as we saw in the definition, there are various configuration options available, and as such, the instance type selected will influence the pricing. Currently, there are over 275 instance types available in AWS, and these can be grouped into the following categories. General purpose instances typically provide the right amount of processing power for a wide variety of use cases, while compute optimized instances are ideal for intensive computing use cases such as scientific modeling, data transcoding, dedicated gaming servers, or high performance web servers. Memory optimized instances run workloads that are memory intensive. Big data processing clusters often take advantage of storage optimized instance types, while graphic intensive applications such as those used to transcode 4K UHD resolutions typically take advantage of accelerated computing. Large complex simulations and deep learning workloads are ideal use cases for high performance computing. Just know that depending on your particular use case, these different categories of instance types will definitely help narrow down the selections for ensuring that you have the capability that you need. And we will explore these different instance types inside of the console during an upcoming lesson, so don't worry, it's definitely going to start to click. Now moving on to root device types. EC2 instances can be launched using either instance store volumes or elastic block store as the root volume. An instance store is ephemeral storage that provides temporary block level storage for your instance. Instance store is ideal for temporary storage like buffers, cache, and other temporary content. Inside of a computer, you have what's called random access memory, better yet referred to as RAM. Think of this as the equivalent of instance store volume, because just like the RAM inside of your computer, the data on an instance store volume persists only during the life of the associated instance, meaning if an instance is stopped or terminated, any data residing on that instance store volume would be lost. An EBS-backed instance means that the root device for an instance launched from the AMI is on an EBS volume, which is typically created from an EBS snapshot. An EBS volume behaves just like a raw, unformatted external block device, similar to a portable network attached storage that you may have seen, which most people call an external hard drive. These volumes persist independently from the running life of an instance, which means that these volumes can be detached from one instance and attached to another. They can also be created as an encrypted volume using EBS encryption feature, and you can have backups for EBS by creating snapshots, which is not possible with instance store. One other thing to note is that typically when you launch an EC2 instance from an EBS-backed an EBS-backed instance will launch successfully within just under a minute, while instance-based EC2s typically take around 5 minutes to launch. So just keep that in mind. Now let's take a look at Amazon Machine Images, or AMIs. An AMI is a template for an EC2 instance that includes the data, the operating system, and the configuration that would actually go on that specific instance. AWS provides many different AMIs that you can leverage, and we will see these in the AWS Marketplace in the very next lesson. Additionally, there are several commercial AMIs and community AMIs within the Marketplace. You yourself can create an AMI and make it public, and it will then become a part of this large set of community AMIs. Custom AMIs can be shared between AWS accounts, and before launching AMIs, they must first be registered. This is a step that previously had to be done with each and every new AMI used in an AWS account, but recently, AWS incorporated a way that allowed them to transparently take care of this on the back end. But there are still a few AMIs that you must register yourself prior to using them. And later in this module, we'll take a look at one of those examples. The final thing that we want to discuss this lesson before taking a tour of the AWS Marketplace is pricing. Amazon EC2 offers 4 paid pricing tiers and a free trial tier. The free trial tier requires you to use only AWS micro instances with no more than 750 hours of Linux or Windows T2 micro instance size. And again, we'll see that in action in just a little bit as well. Now, if you're using a paid instance, AWS updates their prices very frequently, so you'll need to keep checking back with them. But as of this moment, this is how Amazon's EC2 pricing works. On-demand instance allows you to scale up or down your compute resources according to your application needs. You pay by the hour or by the second, so you're not bound by a usage threshold. Just keep in mind that EC2 instances are always running, so until you end them, AWS will continue to charge you per hour or per second. This pricing option might be suitable if you have applications that use an unpredictable amount of resources and at different times. Spot instances let EC2 customers access Amazon EC2 spare capacity for up to 1/10 of the on-demand instant price. Prices depend on how many unused instances there are in inventory. They're also usually available during off-peak hours, so you need to run your instances at this time to take advantage. To give you an idea of what this concept means, let's say that you only wanted to pay 5 cents an hour and you wanted it to be an M5 X large instance. Well, if you put that as your maximum spot price, you would be able to use the capacity for your instance if there was available capacity at that price for that instance type. But as soon as the price raises back above 5 cents, if you weren't willing to adjust your spot price by increasing it, AWS would actually take back that instance within a 2-minute notice. Now, you can choose to pause your instance and resume your work later when you either had another spot price that met or was lower than your reserve. So you can kind of think of this option as bidding for that capacity. Choosing the Amazon savings plan, you can commit to a specific monthly spend instead of an instance family. You can also use the savings plan you commit to with other instances on AWS, such as Lambda functions or Fargate. Dedicated hosts provide you a dedicated EC2 server. Here, the physical EC2 server is dedicated to your use. You can purchase the plan on demand, or you can buy it as a reservation for up to 70% off the price of the on-demand plan. If you're concerned about maintaining compliance or your organization mandates that your servers be segregated from other tenants, then this could be the best plan for you. Similar to savings plan, there's also a reserve instance. With the all upfront option, you pay for the entire reserve instance term with one upfront payment. This option provides you with the largest discount compared to on-demand instance pricing. With partial upfront option, you make a low upfront payment and you're charged a discounted hourly rate for the instance for the duration of the reserve instance term. The no upfront option does not require any upfront payment, and it provides a discounted hourly rate for the duration of the term. AWS recommends saving plans over reserve instances. And like reserve instances, saving plans, of course, offer lower prices. However, saving plans afford you the flexibility to change your usage as your needs evolve. Definitely be sure to check out the reference links to get a clear picture on the particulars of each purchase option, as we provided a very high-level overview here. But to bring these ideas together, let's take a look at the AWS Marketplace. AWS Marketplace is a buyer and seller's online shop with a digital catalog that enables a user to buy and sell software that runs on Amazon Web Services. Customers can quickly launch pre-configured software and choose software solutions in Amazon machine images. Here we see a link for sellers. This is the place to go to find out more information on the process that it takes to get your software inside of the marketplace. The same holds true for AWS partners. Software sold inside the AWS Marketplace covers a range of categories, including but not limited to operating systems, security, networking, storage, business intelligence, databases, DevOps, and software as a service subscriptions. Now let's take a quick look at all the products. Here we see that there are over 10,000 products available in the marketplace, including a variety of products, some from AWS, others from vendors, but there's a lot of variety to suit the needs of each individual customer. Many products offer a free trial where you can evaluate their product before making a purchasing decision. There are also different operating systems that these platforms are built on, to include Windows and Linux. And recently, AWS even added a Mac OS image, and we'll see that when we launch a few EC2 instances in an upcoming lesson. But let's filter the results that we see here to just show us the AMIs. And you can see that there's almost 7,000 AMIs listed. We will be deploying Amazon's Linux AMI as well as a Windows Server AMI, so get familiar with seeing these logos in the EC2 section of the console. But if we keep scrolling, we see that Palo Alto offers a free trial of this next generation firewall bundle. So let's click on it and take a look. Right off the bat, we see that we get a lot of information about this product from the vendor, including the total price, which if you look closer, it's for an M5 2x large instance size deployed in the US East Northern Virginia region. We'll see here shortly how the same AMI deployed in a different region with the exact same size will oftentimes have a different price. This button that says continue to subscribe is where in the previous lesson where we discussed how the first product from each vendor must be registered in your account prior to using it. If AWS were not to take care of this for you, where this link takes you to when you click on it would be where you'd be required to register it. Scrolling down, we see that Palo Alto provides a bit more information about the difference between the various bundles that we have as AMIs for their next generation firewall products. Depending on your requirements, this is part of how you as a cloud professional, when you do your research on a solution, you can begin to narrow down the options that you can provide your client. Now, pricing is typically one of the most important criteria when making a decision. And unfortunately, I've seen personally where decision makers base their decisions based solely on which product could perform the required functions, but came in at the lowest price. So keep that in mind. But in this section, we see a price of $1.84 an hour to use the Bundle 2 software at the M5 2x large instance size and an infrastructure cost of a little bit more than 38 cents an hour, which is the cost to run this software inside of AWS. And if we scroll down here, we see that the instance size with the star represents the vendor recommended instance type. And so adding these two amounts together is how we come up with the $2.22 an hour figure for the total cost to deploy this AMI in the US East region. And we see the specifications for memory, compute, storage, and network by hovering over it. This AMI is available to evaluate for free for 15 days, after which, if not terminated, it will automatically convert to a paid subscription. So always be aware of the terms and conditions when deploying an instance, even if it says free tier. Many times you will be asked as a cloud professional to provide figures for how much a solution will cost. Sometimes a client will want to know what's the cost per hour, per month, per year, and sometimes for 3 years so that they can make budgeting and planning decisions for their organization. This is where the savings plan and reserve instant options come into play. You can provide your customer a significant discount for their solution if they were to make a long-term commitment to use the product inside of AWS. For the vendor recommended instance here, we see that we can receive a 15% annual discount if we elect to commit to 1 year with this product. Hovering over different instance sizes, we see that it would be possible to significantly reduce the cost if we were to elect another size. But as a cloud professional, remember, we always have to ensure that the change in an instance size does not negatively affect the architecture of our design. But regardless of which size you choose, be aware that AWS handles all billing and payments, and the charges appear on the customer's AWS bill. If we take a peek at the annual cost for an M5 large, in the US East region, we see that it's a little bit over 9.5 cents per hour. But in the Asia Pacific region, more specifically in Seoul, Korea, this same size is almost 12 cents an hour. So when gathering customer requirements, also be sure to not make a guess on what region they wish to deploy their infrastructure in, as the price may be different based on that one key piece of information. The usage information section provides us with information on connecting to the AMI once deployed, and different AMIs by different vendors will have very different default credentials. And of course, always be sure to read the end user license agreement and be sure to reach out to support for any questions or concerns. So now that we understand the key concepts pertaining to EC2 instances and we've toured the AWS Marketplace, what's left to do but to go ahead and launch a few instances and get familiar with the process. So if you want to log into your account and follow along with me, go ahead and first ensure that your region selected is Northern Virginia, and then go ahead and navigate to the EC2 dashboard by searching for EC2 in your search bar. Once here, go ahead and click on Instances. And as you can see, we have no instances currently deployed. So go ahead and click on Launch Instance. The default selection is the Amazon Linux AMI, and by default, the free tier parameters are already selected for this configuration, but let's take a look at them anyway. We see here that there are multiple flavors of AMIs for Amazon Linux, but we'll stay with the default one selected, and let's name this instance Linux-Server and scroll down to the instance sizes. As we learned earlier, it is the micro instances, and more specifically the T2 micro ones, that are eligible for free tier. We did not discuss the key pair, but to access a Linux instance via the SSH protocol, we're gonna need to create a key pair. But if you already had created one, you would be able to select it here from the drop-down menu. Amazon will store the public key, but we need to safely ensure that we store the private key so that no one else has access to the key, as this private key provides the authentication for logging in. So always store the private key somewhere safe. And again, let's create a key pair. I'll name this one Linux-key. And when I click create key pair, it'll automatically download the private key. So we're all set there. Now the security group is visible in both the VPC service and the EC2 service, but it's tied to resources such as an instance. So that's why we're going to discuss it here. A security group acts as a virtual firewall for your EC2 instances to control both incoming and outgoing traffic. Inbound rules control the incoming traffic to your instance, and outbound rules control the outgoing traffic from your instance. One thing to know about security groups is that if you permit traffic in a security direction, for example, we will make a rule in just a few moments that permits SSH inbound for just our public IP address. But we do not have to make a matching rule in the outbound direction, as the return traffic will automatically be allowed once we create an inbound rule. This is what is known as a stateful firewall. By default, every security group created allows all outbound traffic. So that's the reason why the inbound rule is the one displayed to configure by default. But we'll see this in just a few minutes. But for now, let's click Edit to modify the network settings. If you recall, we deleted the default VPC that came with the account at the end of our last module, so we should just have one VPC displayed here. But just in case you've created an extra VPC or two, let's select the NYF production VPC that we created, as the subnets in the route tables are already properly configured to allow connectivity. For the subnet, let's select the public 1A subnet, Next up, we will choose Enable for auto-assigning a public IP to this instance. Picking this selection will make this instance publicly accessible from the internet, but if we were to stop or reboot our server, every time we did so, we would get a different IP address for our instance. So in a production network, you don't typically want to pick this method, but for our purposes, it will work just fine. Now it's time to work on our security group. Let's start off by naming ours Linux-SG. And the SSH protocol is the one we will use to connect via command line to this instance. So we'll just leave the default. But because this will be exposed to anyone on the internet, let's change the source type to my IP. And now only our single host will be able to access this instance in the cloud. This is a great security practice to limit the exposure to just the ports that are needed and to just the IP addresses that are needed as well. Give it a description, and once you do, we're all good here in this section. The default storage is good for what we're doing here, but you can see that there are various types of storage which we will discuss in an upcoming module. But for now, go ahead and leave the default selection of GP2. Expanding advanced details, and we have tons of parameters that can be modified to your organization's particular needs. Explore these options and go ahead and learn about what capabilities are offered and just play around in this section a little bit. But we will leave these default settings here and move on to the user data section. This section is where we can enter text or a file to function as a script. It'll execute instructions for our instance, such as if we wanted to set a default username while the instance is launching so we don't have to do it later, or enable a service so that each time the system starts, we don't have to log into the CLI and do so. We can enter that type of instructions here. But we're all good with the free tier selections that we've made. So now let's just click on Launch Instance, and you'll see that our settings were appropriate because right here up top, we can see success. Had there been any issue, we would have seen an error message here. You can also set billing alerts here, but we're all good with the free tier selections that we made. So let's simply click on View All Instances. The instance state is currently pending, and shortly it will change to initializing. But while it's doing that and launching, we can already see tons of details about our instance, such as the private IP address from the subnet that we selected, along with the public IP that we're going to need to access this instance. We can validate that our inbound security group rule is allowing SSH for just our public IP, and likewise, the outbound rule is permitting all outbound traffic. But again, lots of useful information displayed for this instance. Clicking on the Status tab, we see the 2 checks that are performed for each instance that's spun up. And if there's any issues with launching an instance, these won't display a green check mark once the checks are done. But let's wait for those checks to be completed. All right, now that the checks are all good, we see that both have passed along with the status check showing 2 of 2 checks passed here. And on the monitoring tab, AWS tracks and displays various metrics about the instance, such as the CPU utilization and packets processed by the instance. You can change the range to show data from the last hour on to the last 2 weeks. And by enabling detailed monitoring, the metrics are displayed in increments of 1 minute instead of the default of 5-minute intervals. But this will cost you, so we will not enable that setting. One last thing to share before we log into our instance is that you have the ability to show or hide fields that are pertinent to how you wish for the information to be displayed. So clicking on the gear icon here, we can check the fields for, say, VPC ID, subnet ID, and private IP address. And when we click close, we now see that this information is displayed for us. So now it's time to connect to our device. But before doing so, we need a utility that can allow us to do that. So I suggest a utility tool called MobaXterm, and the link will be in the description. There's a free version that's portable, so simply download it for your operating system and then run the executable. So now let's copy the public IP address for our instance. And after launching MobaXterm, paste that address into the remote host field. Next, click on the Advanced SSH Settings tab and place a check in the box beside Use Private Key and click here to search for that private key that you downloaded earlier. Once you have it, simply double click on it. Finally, click OK, and this should start your SSH session. You should be prompted for the username if everything was done correctly. The default username for this particular instance, the Amazon Linux, is going to be EC2-user, all lowercase. And the private key will provide the authentication. And so now once you hit enter, we're logged into our AWS Linux instance. And because our security group allows all outbound traffic, we can see that pings to Google servers are resolving correctly. And a quick curl on a website such as ESPN.com will provide the contents of the web page so we know that we have outbound connectivity from our server, and of course inbound connectivity because we were able to successfully SSH into our instance. That's all there is to launching your very first EC2 instance, so great job there. I'll see you in the next video where we will launch a Windows server. So now that we have our hands dirty with launching our very first EC2 instance, which was AWS's Linux instance, let's try our luck with launching a Windows Server AMI. Back in our EC2 dashboard, we see that we still have our Linux server running. So let's just click on Launch Instance. Before we give our server a name, let's go ahead and select the proper AMI. Let's highlight Windows, and you can see here that it's free tier eligible as well. T2 micro, of course. Now let's take a look at these, and we see the difference that one has less memory than others out of the two free tier eligible. So we'll stick with the T2 micro here. We'll name this one Windows-Server. You can see also there's a Mac OS AMI, as we noted it was recently added to the portfolio. We'll come on down to the network settings and click on Edit. Again, we'll pick the default VPC, the one that we created. And we'll place this one in the public 1B subnet. We'll enable the auto-assign public IP selection, and we'll create a new security group. This one we'll name Windows-SG. We'll copy that name and paste it in the description. Now, Windows uses a different protocol, RDP, which is port 3389, to manage the server. Just like we did for our Linux security group, we'll change the source type to myIP and give it a description. Once you're all done there, we'll check on the configurations for storage. And again, we'll leave this as the default. Now let's simply launch this instance. But we forgot to create our key pair. So let's go ahead and do that now. We'll name this one Windows-Key and click on Create Key Pair to download that PIM file. We'll see that logging in with the Windows device is going to be a little bit different than with a Linux device. After we've downloaded our key pair, let's go ahead and click on Launch Instance to deploy our Windows server. Then of course, click on View All Instances. And we can see here that of course our Linux server is up and running if you left it running, and our Windows server is initializing, but it already has been auto-assigned a public IP address, which is pretty cool. We'll wait for the status checks to, of course, complete here so that we can access our device. We see that we created a tag for the name of our device. And of course, monitoring, it's going to take a while to populate those metrics. But let's go ahead and give it a moment. All right, so it looks like our instance has passed both checks. So now let's go ahead and make sure that our instance is selected and then click on Connect. Once we've done that, we need to get the password so that we can RDP into it. And we can do that by clicking on Get Password. So let's go ahead and choose File and navigate to that PIM file. Once we have that, click Decrypt Password. And this long doozy of a password here is what we're going to need to get logged in. So back in our MOBA Xterm, let's click on Session. And instead of SSH, click RDP. We're going to need to grab that public IP address from the console. So let's go ahead and copy that. We'll paste it into remote host. Now hitting OK here, we see that the username is Andre King, so that's not what we need. But we'll go ahead and let that load up in the background so that it'll prompt us here. If we hit more choices, we can use a different account. And again, we need to type administrator for the username and make sure that the A is uppercase. Copy that long password and paste it in here. I'll select remember me. And so now we're going to have an RDP session to our very first Windows server here. You may or may not be familiar with Windows servers, but to the naked eye, it may look just like a desktop session for a normal Windows computer. But we'll see here in just a minute that it actually has a server operating system. But let's just give it a moment to be all the way up and running. Now that it's up and running, we can see details about this instance, such as the host name, the instance ID, of course, both IP addresses, private and public, the instance size, availability zone, and a few other attributes here. Now that network low to moderate that we chose for the free tier eligible, it's going to constrain us a bit here, and as it's just using 1 gig of memory and 1 virtual CPU. But that's enough to just get familiar with launching this instance. But let's check out the network settings. In the system tray, we'll click on this icon, choose network and internet settings, change adapter options, double click here, and when we click details. Now in our last module, when we set up the VPC infrastructure, we talked about the reserved IP addresses that AWS has. And we can see here that the default gateway, the last octet being .65, is the second IP address of that subnet. And for the DNS server, it is using the third IP address of the VPC. So let's go ahead and close out of there. Now let's click on the icon for the Edge browser and let this page load. We'll open a new tab and go to speedtest.net. We'll hit go here. And we just want to gather the details of the download and upload speeds for this free tier Windows server. We'll give it a few seconds to run its tests. And we can see here that the upload speed is actually almost 10 times that of the download speed, but 46, 47 megs down is still not that bad. And in my opinion, it's more than adequate for a free tier server. Now I'm going to open another tab and just navigate to ESPN, and we can see here outbound traffic looks good. Now to prove that this is actually a server, let's go ahead and click on what used to be the start button, and let's select server manager. Now if we click add rows and features, we get a prompt that says server manager is collecting inventory data. The wizard will be available after data collection finishes. So even if we go ahead and expand all servers, we still are going to have to wait until the server is done fully fetching its data. So great job deploying your very first Windows server as well as your first Linux server. If you're all done, go ahead and highlight both servers and then go ahead and shut them down so that you can preserve your free tier hours. But again, great job, superstar, and I'll see you in the next video. So before we get started on our EC2 hands-on project, we're going to learn some of the key concepts related to the AWS Elastic Load Balancer service. The primary function of an Elastic Load Balancer, commonly referred to as an ELB, is to help manage and control the flow of inbound requests that are destined to a group of targets by distributing these requests evenly across the targeted resource group. These targets could be a group of EC2 instances, Lambda functions, a range of IP addresses, or even containers. The targets defined within the ELB could be situated across different availability zones or all placed within a single availability zone. Let's look at this from a typical scenario. Let's suppose you have just created a new application, which currently is residing on a single EC2 instance within your environment. This application is being accessed by a number of users. At this point, your architecture can logically be summarized as shown. Using a single instance approach isn't too ideal, although it would certainly work and provide a service to your users. However, this infrastructure layout brings about some challenges. For example, the single instance where your application is located can fail, perhaps from a hardware or software fault. And if that happens, your application would not be able to serve the users and it would be unavailable until the instance was restored. Also, if you experience a sudden spike in traffic, your instance may not be able to handle the additional load based on its performance limitations. To help strengthen your infrastructure and to help remediate these concerns, you should not only introduce redundant servers, but also incorporate an ELB to intelligently spread the traffic across these targets. As you can see in this design, the AWS ELB will act as the point for receiving incoming traffic from users and evenly distribute the traffic across a greater number of instances. By default, the ELB is highly available and it's a managed service provided by AWS. So they ensure its resilience so that we don't have to. Although it might seem that the ELB is a single point of failure, in all actuality, it's in fact comprised of multiple instances that are managed by AWS. Also in this scenario, we now have 3 instances running our applications. So if any of these 3 instances were to fail, the ELB would automatically detect a failure based on the defined metrics and divert any remaining traffic to the 2 healthy instances. And if you were to experience a surge in traffic, the additional instances running your application would be able to help spread that load. Currently, there are 3 ELB types available within AWS to choose from. First, the application load balancer, which we will be focusing on in our hands-on project. It provides a flexible feature set for your web applications running either the HTTP or HTTPS protocols. The application load balancer operates at the request level, and it also provides advanced routing, TLS termination, and visibility features targeted at application architectures, which allow you to route traffic to different ports on the same EC2 instance. Next, there's a network load balancer. This ELB is used for ultra-high performance for your application while at the same time managing very, very low latencies. It operates at connection level, routing traffic to targets within your VPC, and it's also capable of handling millions of requests per second. Finally, the AWS Gateway Load Balancer is an elastic load balancing service that allows customers to insert third-party virtual appliances such as firewalls, intrusion detection and prevention systems, and a host of other appliances transparently into the traffic path. The AWS Classic Load Balancer was retired in 2022. For every load balancer, regardless of the type used, you must first configure at least one listener. The listener defines how your inbound connections are routed to your target groups. The configurations of the listener itself differ slightly depending on which ELB you've selected. A target group is simply a group of resources that you want your ELB to route requests to. For example, a fleet of EC2 instances. You can configure your ELB with a number of different target groups, each associated with a different listener configuration and associated rules. This enables you to route traffic to different resources based upon the type of requests. Rules are associated to each listener that you've configured within your ELB, and they help define how an incoming request gets routed to which target group. Your ELB can contain one or more listener, and each listener can contain one or more rules, and each rule can contain more than one condition. All the conditions in the rule equal a single action. We will definitely get a clearer idea of this in our project, so just you wait. The ELB associates a health check that's performed against the resources defined within the target group. These health checks are very important as they are what allows the ELB to contact each target using a specific protocol to receive a response. If no response is received within a set of thresholds, then the ELB will mark the target as unhealthy and it will stop sending traffic to that target. There are 2 different schemes that can be used for your load balancer, either internal or internet facing. The nodes of the ELBs that are defined as internet facing are of course accessible via the internet, and so they receive a public DNS name that can be resolved with a public IP address. This would be in addition to an internal IP address that the ELB receives as well. This allows the ELB to serve incoming requests from the internet before distributing and routing the traffic to your target groups. When your internet-facing ELB communicates with this target group, it will only use the internal IP address, meaning that your target group does not need public IP addresses. An internal ELB only has an internal IP address. This means that it can only serve requests that originate from within your VPC itself. For example, You may have an internal load balancer sitting between your web servers in the public subnet and your application servers in the private subnet. This now brings us to the end of this lesson, but now it's time for an overview of our EC2 course project, where we will incorporate an internet-facing application load balancer. For our EC2 course project, leadership has given us a challenge to further our knowledge and understanding of EC2 instances and elastic load balancers. The topology displayed here depicts users making HTTP requests that are hitting the front end of an application load balancer. We see two different target groups and a few rules there configured as well. On the back end, there's two AWS Linux hosts, one in the US East 1A availability zone and the second in US East 1B. So taking a look at those challenges, first off, we see that we need to deploy a second AWS Linux instance in the public 1B subnet. We already have an AWS Linux instance in the public 1A subnet, so this is something we're going to take care of early on. Next up, we need to enable the HTTPD service and configure a simple web page. This will give us a little bit more experience inside of the CLI and the Linux operating system. Third, we'll configure an ALB, which of course is an application load balancer that will target both Linux instances on port 80. We'll have to create a separate target group for each, but the fourth challenge here is a head scratcher, as we have to figure out a way to incorporate those rules that we see displayed in the topology. If I had to take a guess, the difference is going to come down to where the source IP address is. And last but not least, to wrap it all up, we need to come up with a way to demonstrate a way that's going to validate that this solution is actually successful. So we've got a lot on our plate, so let's go ahead and jump right into it. Before we go ahead and implement the solution for our EC2 project, let's go ahead and do a quick recap of what our manager wishes us to do to successfully meet the challenge that he's laid out before us. We see here again in this topology that users are going to be making web requests across HTTP, which is port 80, to an application load balancer. Once that traffic hits the front end, there are going to be two different target groups targeting two different Linux EC2 instances, one each in a different availability zone. We see the rules here that we need to figure out what that actually means. But again, let's go through each of these challenges real quick and let's go ahead and set up a game plan. So first off, we need to deploy a second AWS Linux instance in the public 1B subnet. Now, just a few lessons ago, we became very familiar with the steps that are required for launching an EC2 instance, so this shouldn't be too tough of an ask. Next up, we need to enable HTTPD service and configure a simple web page. This is actually going to give us some experience in the Linux CLI, as this is going to be the service that's going to allow us to enable the web server, more specifically an Apache web server, so that users can use the internet and hit these EC2 instances and be served the web page that we have configured there. Configure an ALB with both Linux instances as targets on port 80. This and the remaining three steps are actually going to be all about ensuring that we have the proper configurations for the ALB and its subcomponents. So we're going to bring this back up when we get to that point so that we can refresh our memory. We're going to baby step this through and talk this solution up along the way. So let's go ahead and head to the console and get started with deploying that second Linux instance. In the web console, both the Linux and Windows server for me are actually stopped here. So if you have yours running, then go ahead and simply highlight it, click actions, and under instance state, go ahead and stop it to shut it down. And then once you're there, let's go ahead and follow these steps. We're going to first start off by renaming this Linux server. So let's hit the pencil icon there, and we're going to append a -1A so that we can differentiate the Linux server that's going to be in this subnet, of course 1A here, and the one in 1B. While we have it highlighted, let's next click on Actions, Launch More like this. And what this is going to do is it's going to load most of the configurations that that first server had. And the first thing that we're going to want to do is ensure that the number of instances we wish to or desire to launch is still at 1. Once we have that, let's change the name, of course, to 1B. We'll scroll down, and as we can see, it's still free tier eligible because the instance type is still T2 micro. We're going to choose and select the same key pair to make it a little bit easier to manage. So go ahead and select the Linux key. The VPC, we still should only have one, but just in case, let's select NYF production, and recall this needs to be in public subnet 1B. So let's change that. We need a public IP address, so we will enable the auto assignment of that. And for the security group, we're going to use the same Linux security group that we created a few lessons ago. Other than that, everything looks good. So let's simply launch our instance. Now, when we head back to the console and take a look here, the launching takes a little bit to make sure that everything's okay on the back end. But once we have our public IP address, we can actually start to see if we can log in using, of course, Mobex term, the portable application that we're going to use here. But while this server's spinning up, let's go ahead and select our original Linux server, and let's go ahead and start that one up. Now let's refresh this page here, and we have our public IP even though both servers are starting up. So I'm gonna bring over my MobaX term session here, and we can get rid of these two previous sessions. Again, when you auto assign a public IP address, it's gonna change each time the instance stops and is rebooted. So we don't need to save those. Next, click on session, pull this down so we can see SSH. And I'm simply going to type in each of these public IP addresses, starting with the one that's in availability zone 1A. Again, your IP address will be different. Next up, click on the Advanced SSH Settings tab, place a check and use private key. And now we need to find that PIM file, which is Linux key -pim. Click OK. Now our default username again is EC2-user. So we're into our very first server. Let's get another session going and type in our next public IP address, 34.200.237.157 for me. Same process for the private key. And of course, the same default username. Cool. Now that I'm connected to both sessions, I'm going to make this full screen. The cool thing, or one cool feature of MobaX term, is that you can actually split screen. And by doing this multi-exec button, which we're going to click here, we can send commands to both of these sessions. So again, we have 1A on the left, 1B on the right, but we've now successfully met the first challenge of launching a second EC2 instance Linux AMI and the public 1B subnet. Now it's time to install Apache Web Server and do a basic configuration. So let's go ahead and first type this command sudo, spell it right, sudo, yum install httpd. And there is a flag that we can put, which will do the rest of the way -y, so that we're not prompted to validate that we want to do this. But because we didn't put that -y, let's go ahead and type Y and then press enter. And this is simply installing the Apache Web Server. Now, sudo allows us to perform administrative tasks without actually changing to that root user. So we're going to type this for each of these commands, or prepend it to the front. Next up, we need to start the web server. So type sudo systemctl start httpd. And once we have that started, this next command we don't specifically need for this task, but if you want to play around with it or commit it to memory, it's pretty good. If this server were to restart right now, then we'd have to come back into the CLI and start this web server again. So one way to prevent that is to perform the command sudo systemctl start httpd, and it's going to start it every time this web server boots up. Oh, apologies. Enable. I'm up here brain dead. There we go. All right, there we go. And then last but not least, to check and make sure that this service is running properly, let's do sudo systemctl status httpd. And as we can see here on both servers, we have this service, the Apache HTTP server, actively running. So it's pretty cool. Again, we're typing these commands to execute across both servers, so we don't have to come back and do it to the second one. So pretty cool there. So now our web server is up and running. And if we were to, let's go ahead and minimize this. Let's just take one of these public IP addresses. We'll use the one in 1A. And if we paste this into another tab, if we were to wait, we would notice that the web page is actually not going to load. Our session actually is directly to each of these separate instances, but our security group is only allowing traffic on port 22 for our public IP address. It's the only port that's allowed inbound. So we need to go modify the security group so that we can allow port 80 traffic inbound. And that's why this isn't loading right now. So let's go back into the console. And again, just to validate, we'll hit view inbound rules. And there we go. We can see only port 22 is currently allowed inbound. So I'll right click this security group to just place it in a new tab. All right, once this is loaded, let me click inbound rules, edit inbound rules. And for now, we're going to add HTTP as the type, which is port 80. And I'm going to put my IP, and I'm going to copy this description just to get in a good habit in case someone were to come behind. I should put my name instead of my IP though. All right, there we go. So now if we were to refresh this web page, we'll see that the Apache web server by default has this test page. And if we were to come back into the console and copy the public IP for our server sitting in 1B, same thing. But we need to think of a way, thinking ahead, when we get all the way to the final task, validating this. Want to make it easy for ourselves. One way of doing that is actually doing a custom script. So if we come back here and take a look, we see that for our server residing in 1A, this needs to do something or have some kind of rule that targets this specific server when traffic comes from my IP address. But for every other source, it's going to forward traffic to the one in 1B. So let's think about this. If we go back to our MobaXterm session, we can actually create a landing page with a message, but we can make it different for each server. So because of that, let's go ahead and exit multi-execution mode. There we go. So we're still on both our servers. So let's validate just in case. So 0.50, you want to always validate, even if you're almost certain that you're on the right server. So the private IP of 0.50 is actually the one that's in 1A for me. So I'm going to configure that one first. And let's go ahead and change CD for change directory to /var/www/html. And there shouldn't be any file here right now. So we're going to create a index.html file with sudo vi index.html. All right. So now this file, of course, is empty, but this is our HTML, which of course is the language of the web. And we'll press the I button to insert. And now we can begin typing. So we need to use HTML format. So all HTML needs to begin with an HTML tag. So bracket HTML, close bracket, we'll press enter. Now let's create an H1 tag. And an H1 tag is going to make the text appear pretty big. And let's type a message here that will make sense for my IP address. Type a message that says Andre King, and you can put your name, is accessing this web server. And now we'll close these tags by placing a slash in front of the same thing. So /H1 to close the H1 tag and slash HTML to close the HTML tag. Now to exit properly, press escape, WQ to write to this file and quit. And then we will do the same thing for our server in 1B. So let's change directory, cd to /var/www/html, sudo vi index.html, press an I to insert, HTML tag, h1 tag. And for this one, we will put Andre King is not accessing this web server. Slight change there. This is just for anyone else that doesn't have our IP address. Now again, let's close the h1 tag and close the HTML tag. Let's see. There we go. Escape, WQ. All right, there we go. All set. So now let's go back to our browser. And again, we have these test page open because we didn't have any HTML page that was customized. So if we were to refresh each of these pages, starting with 1A, we see the text that we put, Andre King is accessing this web server. And for our second, the one residing in 1B, Andre King is not accessing this web server. So now we have a way of knowing which server the load balancer is forwarding to in the browser without having to manipulate anything, look through logs, or do anything fancy. So not the prettiest, but again, functionality, and for our simple tests, it's pretty easy for us, and we can explain this to someone else. So you don't always have to do anything elaborate when you're in the lab testing. But now it's time to configure our ALB and the remaining tasks. So we're going to break this video up into 2 parts. So I'll see you in the next video. Welcome back to our second part of the EC2 project. In the first part, we were able to successfully deploy our second AWS Linux instance, and we configured an Apache web server with a customized simple web page. So now it's time to go on to the third challenge, which is to configure an ALB with both Linux instances as targets on port 80. And of course, let's go ahead and take a look at these rules so that we can think this through as well. Once we make our target group 1, we're going to have to think of a way to create a rule once it's tied to the ALB so that only traffic that's coming from our IP address on port 80 is going to be forwarded to the server that's in subnet 1A. Subsequently, any other traffic that's not our IP address is going to match target group 2, and it's going to forward it on to the server that's in subnet 1B. So pretty exciting, but to go ahead and implement this solution, let's go ahead and head to the console. So back in the console, we see that our 2 servers are still up and running. So now to configure the ALB in the target group, let's head to the left side and scroll down underneath the load balancing category. And for the load balancing and target group, you could honestly configure either first, because if you configure the load balancer, there's a step that's going to ask you to select the target group or create one. But for us, we're going to actually create the target groups first. This is typically the order that I do it in. So click on target groups and then of course, create a target group. Now for the target group name, let's just name ours ALB-target group -1A. We'll leave the target type as instance, protocol, HTTP, and port 80. We only have one VPC, but ensure that it's selected. And for the health checks that we discussed in a previous lesson, these are the standard and default health check settings. So this is going to do a probe or on port 80 to the root, which again, we do have an index.html page, and it's going to perform this at a 30-second interval with a 5-second timeout. So for an instance to go unhealthy, it's going to have to fail 2 health checks. If we needed to make this more aggressive, we can tweak these parameters, but we'll leave these as the default for now. So let's go ahead and click create. All right. Let's now click create target group again, and we'll do ALB-target-group-1B And again, we kept all the default, so we'll do the same here and we'll create that target group. Now that we've created our target groups, we can register the targets here, but we'll go ahead and do it in the load balancer section. So now let's create the ALB by clicking on Create Load Balancer and selecting the application load balancer and clicking Create. We'll give this a name of ALB. And this, of course, it needs to be internet facing as the users will be coming in across the internet. The listener is going to be the default of HTTP on port 80. And we have to select at least 2 availability zones, which of course we have 2, so we're good to go there. So place a check in both 1A and 1B, and we're going to target the public subnets in each of those availability zones. For the tags, let's go ahead and give this a name, and we'll copy the name up top, which is just ALB. So we'll just type that in. All right, let's see, ALB. And then next, configure security settings, which we don't have 443, so we'll skip that. And for our security group, let's go ahead and create a new security group. We will name this one, we'll name this ALB-security group. We'll give it the same description. Our security group needs to accept traffic coming in on port 80, which is HTTP, and we'll accept this from anywhere as users all across the world need to be able to make a request. The default of custom is that, but let's select anywhere. And next, click routing. This is where, again, I noted that if you did create the ALB first, you could either select a target group here or create a new one, but we'll select existing and choose ours from the dropdown. Now, here we have to, again, think about what was asked in step 4. For any traffic that's not our IP address, we should probably select the target group being 1B, which is the one that has the message, Andre King is not accessing this web server. That way, logically, we can create a rule just for our IP address that will then forward it to 1A. So either way will work, but you have to think about the logic. So we're going to use that logic, and we're going to make our default target group forward traffic to the Linux instance that's in subnet 1B. Next, we'll register targets. There's no targets registered here, so we'll have to come back and do that. And everything looks good. Check that, though, and hit create. Now let's go back to target groups. That's where I typically register during that step. So we'll start with 1A, we'll click edit, and then select the one that's in zone 1A, which of course has the name ending in 1A. Click add to register and then save. And now this instance is registered to this target group so that traffic can be forwarded to it. We'll select 1B and we'll do the same. Click edit, select the one that's in subnet 1B, add to register, and hit save. Now you can see here in the description that the target registration is in process, and I'm going to warn you, this actually is going to fail. Traffic that is currently coming into our instances directly only have 2 rules. The security group for inbound is allowing port 22 and port 80, but only from our IP address. But what an ALB does, if you recall the ELB overview, is it gets 2 IP addresses. It gets a public IP address, which I call forward facing. And so that's actually where users on the internet, when their requests are coming in, it actually hits that public IP address. But the ALB then looks at its target groups and its rules, and depending on the conditions, which again, we'll see in just a little bit, it forwards that traffic to the relevant target using the private IP address. So we actually need to add the private IP address of the ALB for each subnet to that security group. So again, let's see if this is done just yet. Status of unhealthy. There we go. So to get that, what we can do again, and we're getting familiar with the EC2 menu, and always feel free to explore on your own, but if we right click here on network interfaces and come back here, let's see, We do have our security group created. We're going to go ahead and open it and get ready. Here we can actually scroll to the right, and under description, we'll sort it by that. We see our ALB interfaces, one for each subnet, 1A and 1B. And so this is going to give us information on the private and the public side, but we need the private IP address for the ALB for each subnet. So we'll copy this. We'll go ahead and add two rules, HTTP, and we'll paste that in on /32. We'll call this ALB 1A private IP. We'll come back here to our other tab. We'll click on the one that's in 1B, again, for the ALB. And we'll copy this private IP address, our second, and we'll paste it in here, /32. We'll make our description 1B, ALB 1B private IP, and we'll save that. And now if we were to go back to the target groups, the one that has ALB, which is the default, and we saw the intervals, but we'll have to wait for this again to do its next health check. So we'll wait a moment just to make sure that this does come back successfully. But while that is actually waiting to happen, let's go ahead and create our rules. So going back to the load balancer, what we need to do here is implement the solution for the logic of those rules. So let's go to listeners, and we see here that currently the default is forwarding traffic to the target group of 1B, which has a condition of forwarding traffic to the Linux instance that's in 1B. So if we view and edit rules here, we see that same default action of forwarding traffic to the target group 1B. But if we click this plus icon here and then insert a rule, we have a few conditions that we can do. So again, what we're trying to do is to force traffic that matches, whose source matches our IP address. We need that to be forwarded to the instance up here and not the default rule that's forwarding everything to the instance in subnet 1B. So if we click this drop down, we see different conditions, different attributes that we can use. But of course, for what we're trying to achieve, we need the source IP. And to get our public IP, there's several websites, but what is my IP is a pretty cool one. So gonna copy my public IP. And again, you wanna copy yours, not this one. And then we'll come right back. Am I getting lost? Back to the rules and paste that in. And we need to add a /32 to the end, which is a single host. It's just one IP address. Next, we need to, of course, do the action. So what this is saying that if the source IP is my public IP address, again, yours will be here, then do this. So our action is going to be forward to the target group of 1A. And the traffic distribution default is 100% because we only have a single instance there. And once that's done, we'll hit save. There we go. All right, cool. So now if we were to come back here into our console, let's take a look. Let's refresh. And we see that now the target is healthy. The same would be for, of course, 1A now that we have that rule there. So now instead of hitting the individual instances across their public IP address, we need to find the DNS A record. And this is going to be routable on the public internet. So if we paste this in our tab, let's see what this does. It's going to load. Andre King is accessing this web server. And again, the reason being is because even if I refresh here, we see that my public IP address, of course, is allowed in the security group, and it's matching that rule, the first rule that's going to forward it to 1A. So we need a way, our final step to validate this or to demonstrate it. How can we now from our computer, which has the public IP address that we want it to, how can we make traffic go across 1B without changing our public IP address? Well, great question. If you're using Google Chrome, there's some extensions that they have, and a pretty handy one here, if we go ahead and click Manage Extensions, is actually this free VPN for Chrome, a VPN proxy. So I'm going to enable it, but if you don't have it, go ahead and install it. It's pretty cool to use. And then once I have that, I'm going to come back here, click this. And what this does is it's going to let me pick VPN from certain countries. If I'm using the free version, which I suggest you do, then each of these radio buttons that don't have the lock, you can make your IP address look like it's coming from that country. So I'm going to go ahead and stay here on London, the UK. So let me go back. And then to power it up and basically change our public IP address, click this button here, which is kind of like powering it on. Continue for free. And this now is my public IP address, 45.159.248.157. If I come back to this tab here and refresh the page, we see that my public IP address has changed to look like it's coming from Germany. So now coming right back to our tab that has that DNS name, if I click refresh, now traffic is targeting 1B, the default target group, which has that default rule that's forwarding traffic to the second Linux instance. So again, this has satisfied all conditions of our challenge. You did an amazing job, learned so much, and we put a lot of different thoughts, concepts, and knowledge to use here to perform a solution. So definitely excited and happy for the progress that you're making. Hoping that you enjoyed yourself and continue to test yourself here. Again, there's different things you can do on the free tier, but like we said, for this EC2 project, we have successfully demonstrated our competency and we've met each and every part of that challenge. So in our next lesson, we're going to quickly clean up our environment. So I'll see you in the next video. So real quick here, to clean up our environment from our EC2 module, let's go ahead and head on to the console. And as you can see, 2 of our servers are actually running. We don't need these servers, so I'm going to select this box to highlight all of them, click Actions, and then under Instant State, I'm going to actually hit Terminate and validate that by clicking Yes, Terminate. We're going to let that run. And now, of course, we have our ALB and target groups. So actually, we need to delete our load balancer first. So highlight this, click Delete, Yes, Delete to confirm. And then underneath the target groups, we can select, again, both of them, click Actions and Delete. And then we're good to go. Now, we do have a few extra security groups that we can take care of here. I've got a few as well from playing around, so we can go ahead and delete each of these as well, and we'll leave the default VPC security group. Highlight those, Actions, Delete security group, and to delete multiple items here, type the word delete, and then click Delete. Now let's validate and confirm that we don't have any remaining volumes or EBS here, which again, it takes care of deleting those if you leave the default on those instances when you're launching them. So we should be good to go as the instant state is terminated. So great job during this module as we saw how to not only create EC2 instances, but also how we can provide high availability by using elastic load balancers. Super proud of you, superstar, and I'll catch you in the next video. In this module, we're going to be exploring the various file storage services offered by AWS. We're really going to be looking primarily at 3 different services, and although AWS offers data transfer services, we will focus on the different file storage options offered, as understanding these will be very valuable day one of going into any organization. So that's what we're going to cover, but let's talk about how we're going to cover that within this module. First up, we will introduce each of the primary file storage services and learn a little bit about what each brings to the table, as well as go a little deeper with understanding the typical use cases for each. Next, we'll be looking at Amazon's Elastic Block Store, or EBS. We touched a little bit upon this when we launched our first EC2 instance, but we will explore it in a bit more detail, as well as introduce Amazon's Elastic File System, or EFS, and we'll explore both of these within the AWS console as well. Next, we'll take a look at Amazon S3, and this is one of the core AWS services, so we will go a little bit deeper on this one as well. We'll conclude this module with a demonstration where we will actually be implementing a static website using Amazon S3. Hopefully that sounds exciting to you, but let's go ahead and hop into the next video. I want to start off by providing you with a brief introduction as to why there are so many AWS storage services to choose from. Part of the answer lies in the rapid change and growth that has been experienced recently as more and more organizations are moving and migrating to the cloud to take advantage of the benefits that cloud offers, such as scalability, flexibility, high availability, and cost efficiencies. AWS offers many different services that take advantage of these benefits. So back to the question of why does AWS provide so many different storage services? Well, it's essentially the same reason why there are a range of storage products and solutions used in on-premise environments. For example, many environments are likely using different storage devices such as storage area networks, often known as SAN, network attached storage, commonly referred to as NAS, directly attached storage, and also tape backups. It's not important to understand in detail what each of these solutions are and what they do. The point I'm trying to make here is that they all perform the same function, the ability to store data. But at the same time, each solution also provides different benefits and features, such as cost variance, security features, storage capacity, encryption and access control, various levels of durability and availability, different media types, different read-write speeds, and also backup and file storage solutions. Not all your data needs to be treated exactly the same, and oftentimes, data can require very specific requirements. This is the reason AWS has so many different storage services available, to allow you to select the most appropriate service for your needs. Understanding which AWS storage option can provide these features for you is critical to being able to select the most appropriate solution for your organization. Data storage can be categorized between block, file, and object storage, and let's quickly discuss each. Block storage stores data in chunks of data known as blocks, and these blocks are stored in a volume and attached to a single instance. In our last module, we got familiar with EBS, or AWS's Elastic Block Store. That's an example of block storage, and these types of storage generally provide very low latency and can be considered similar to your directly attached disk within your own data center. File storage is data that stores separate files within a series of directories, forming a data structure hierarchy. The data is then stored on top of a file system and provides shared access, allowing for multiple users to access the data. File storage in AWS can be associated to your network attached storage systems you may have in your own data center. If you've ever used Google Drive or Dropbox, this is very similar to the concept of file storage. With object storage, each object does not conform to a data structure hierarchy like what's seen in file storage. Instead, it exists across a flat address space and is referenced by a unique key. Each object can also have associated metadata to help categorize and identify the object. Now that you have an understanding of why AWS has developed a range of storage services for you to select from, let's start by taking a look at each of these services individually so that we can know when and why we may need to use each service. AWS's Elastic Block Store service, EBS, provides persistent and durable block level storage. EBS volumes can be attached to your EC2 instances and are primarily used for data that's rapidly changing and might require specific input-output operations per second rate, which is also known as IOPS. EBS volumes are independent of the EC2 instance, meaning they are logically attached to the instance instead of directly attached, like instant store volumes. Because of this, even when you shut down your EC2 instance, the data contained on the EBS volume is persistent, and it's still there when you start your EC2 instance again. Due to EBS's ability to enforce persistence of data, it doesn't matter if your instances are intentionally or unintentionally stopped, restarted, or even terminated. The data will remain intact when configured to do so. EBS also offers the ability to provide point-in-time backups of the entire volume. These backups are known as snapshots, and you can manually invoke a snapshot of your volume at any time. Snapshots are also incremental, meaning that each snapshot will only copy data that has changed since the previous snapshot was taken. Once you have a snapshot of an EBS volume, you can then create a new volume from that snapshot. So if for any reason you lost access to your EBS volume, you can be confident that the data will be recreated from the volume from that snapshot, and then you can attach the volume to a new EC2 instance. To add additional flexibility and resilience, it is also possible to copy a snapshot from one region to another. Speaking on the topic of high availability and resiliency, your EBS volumes are by default created with reliability in mind. Every write to an EBS volume is replicated multiple times within the same availability zone of your region to help prevent the complete loss of data. This means that your EBS volume itself is only available in a single availability zone, and as a result, should your availability zone fail, you will lose access to your EBS volume. Should this occur, you can simply recreate the volume from your previous snapshot and again attach it to another instance in another availability zone. There are two types of EBS volumes available, each with their own characteristics. These being solid state drive back storage and hard disk drive back storage. This allows you to optimize your storage to fit your requirements from a cost to performance perspective. SSD back storage is better suited for scenarios that work with smaller blocks of data, such as databases using transactional workloads, or often as boot volumes for your EC2 instances. On the other side, HDD back volumes are designed for better workloads that require a higher rate of throughput, such as processing big data and logging information, so essentially working with larger blocks of data. Both of these volume types can be broken down even further, and depending on the use case for your EBS volume, you can select the most appropriate type. The performance of volumes change frequently, so for the latest information on these volume types, always refer to the current AWS documentation. First up is provision IOPS. These volumes deliver enhanced predictable performance for applications requiring I/O-intensive workloads, which of course is input-output. When working with these volumes, you have the ability to specify the IOPS rate during the creation of a new EBS volume. And when the volume is attached to an EBS optimized instance, EBS will deliver the IOPS defined within 99.9% of the time throughout the year. The throughput optimized HDD volumes are designed for frequently accessed data and are ideally suited to work well within large data sets, requiring throughput intensive workloads, such as data streaming, big data, and log processing. These volumes deliver the expected throughput 99% of the time over a given year. And an important point to make is that these volumes can't be used as boot volumes for your instance. The cold HDD volumes offer the lowest cost compared to all other EBS volume types. They are suited for workloads that are large in size and accessed infrequently. They will deliver the expected throughput 99% of the time over a given year. And again, it's not possible to use these as boot volumes either for your EC2 instances. One great feature that EBS offers is the ability to enhance the security of your data, both while in motion and at rest, through data encryption. This is especially useful when you have sensitive data, such as personally identifiable information, or PII, stored in your EBS volume. In this case, you may be required to have some form of encryption from either a regulatory or governance perspective. EBS offers a very simple encryption mechanism, simple in the fact that you don't have to worry about managing the data keys to perform the encryption process yourself. It's all managed and implemented by EBS. All you are required to do is to select if you want the volume encrypted or not during its creation via a checkbox. All storage volume options support encryption. Now, to get a better understanding of EBS volumes, let's hop into the console and take a look. Now let's hop into the console and take a look at the EBS service. From the EC2 dashboard, let's first take a look at our Linux EC2 instance that we previously created. Let's click on the instance that we created, and if you scroll down here and click on the storage tab, you're going to see that when we created our first virtual machine, that the instance creation process automatically associated one EBS volume to our instance. And just to take a quick peek at that for a reminder, let's go ahead and do a sudo launch of a new instance by clicking on Launch Instances. All right, here we go. We can see here that the 8 GB volume is auto-selected to stay in the free tier eligibility right here. And so this is what we selected for our Linux instance, if you recall. So let's go ahead and cancel out of that. But when you create your virtual machine, you do need to have storage or a disk to put the operating system of your virtual machine, right? The place for that is an EBS volume. You can see it's connected to this virtual machine. It's also logically mapped to this device. As we noted earlier, the volume size is 8 GB. And we did not encrypt our data here as we're getting familiar with the environment. But if we did, we would get that piece of information right here. So we're getting shown all the data from this particular block storage volume. Earlier in our overview, we discussed creating snapshots of our EBS volumes to take point-in-time backups. So all we need to do is select our volume. And here we're going to right-click and open this up in a new tab. And we're going to get familiar with snapshots here real quick. So let's highlight our volume. And now if you click on Actions, then click Create Snapshot, you see here that you simply need to provide a description and optionally a tag to create a snapshot of your volume. Typically, you would want to take a snapshot while the device is powered off, but in a production environment, this isn't always feasible. Now, as the snapshot is getting created, we can see the progress here. And once the process completes, you now have a backup and a very easy way to restore your disk, which is from the snapshot. Additionally, we can create a volume and provide the parameters that you see here. I'll make a 1 GB volume in the same availability zone as our current instance. And if we wanted to encrypt our volume, as you can see here, Amazon EBS encrypts our volume with the data key using the industry standard AES 256 data encryption. And this key is auto-generated by AWS. All snapshots and any subsequent volumes created from those snapshots would be encrypted and use the same AWS key. For now, we'll leave this unencrypted and then click Create Volume. Next, we will attach it to our Linux instance by going to Actions and selecting Attach Volume. Then we will select our instance. Now, if we go back to our EC2 instance, we see here that we have 2 volumes attached. And to detach it, it's as simple as going back to the volume, highlighting it, under Actions, clicking Detach Volume. And when asked if we're sure, simply click Detach. Give it a moment, and then refresh your screen. And you can see that it's available again to attach to this or another instance. Pretty easy, right? So now you can see why EBS is such a popular service and there's so many organizations using this service. So go ahead and jump into the console and get your hands dirty, but try to stay underneath the free tier limit of 30 GB, and I'll see you in the next video. Amazon Elastic File System is a simple, fully managed cloud-native file system. EFS provides serverless shared storage, meaning you don't need to provision or manage any infrastructure or capacity. AWS takes care of that for you. EFS supports up to tens of thousands of concurrent clients, meaning it's a shared service. It's also elastic and can grow to petabytes in size. You only pay for what you use, and performance automatically scales with capacity, and it's highly available and highly durable. In terms of performance, it provides low consistent latency and high throughput in IOPS. Additionally, EFS offers multiple storage classes, as we'll see here shortly. Now let's go ahead and hop into the console and take a quick look. In the AWS Management Console, EFS is located under the storage category. An EFS file system can literally be created in seconds by simply clicking on Create File System. Here you have the option of naming it. Next, we assign it to a VPC and select regional or one zone. Then click Create. The file system is now available and has been configured with the default values. Now let's customize the creation of an EFS by creating another one and going through the wizard. So this time we'll walk through the customize steps and explain each setting in more detail. Once again, you can see that we have the option of naming the file system. Next, we'll assign it to a VPC. If you're planning to access this file system from on-premise, be sure to select a VPC that's routable between the two. Amazon EFS offers the choice of creating the file system using regional or one-zone storage classes. Regional storage classes store the data within and across multiple availability zones. One-zone storage classes store the data redundantly within a single availability zone, which comes at a lower cost for workloads that don't require multi-AZ resilience. Now if we click Customize, we'll take a closer look at the options, and we can see here that by default, automatic backups are enabled, and we'll create a daily snapshot of the file system. And you can also leverage lifecycle management by specifying the number of days that must elapse for an inactive file to move to the infrequent access tier. For performance considerations, most customers will select general purpose. However, certain workloads such as big data analytics may benefit from the max IO setting. Please note that this setting cannot be modified once the file system has been created. Along those same lines, the bursting throughput mode will meet many customer requirements. This mode automatically scales throughput as the file system grows. You can also select provision and specify a fixed throughput in megabytes per second. Your data is encrypted by default, and like any AWS service, you can always add tags to help identify and track your resources. Because we selected regional for the availability, EFS automatically created a mount point for all availability zones within that region. This screen gives you the ability to specify the subnet IP address and security group for each mount point. Had we selected one zone, we would have only seen a single availability zone on the screen. Finally, you have the option of overriding the default file permissions, but we'll keep the defaults. Now we see that the file system is available. Since it's empty, the capacity is only 6 kilobytes. The next step is to attach this file system to a Linux host. We'll be using our existing Amazon EC2 instances to demonstrate the integration between EC2 and the NTFS file system. But let's sudo launch an instance to see where the setting is to attach an EFS during EC2 creation. We'll scroll down, and as we can see here in the file system section, you see that you can attach an existing EFS file system. But let's go ahead and cancel on out of here. Just wanted to show you that though. Now let's demonstrate how to manually attach a file system. When you click on Attach, you'll see a couple of commands to mount the file system. We'll need to copy this bottom one into our clipboard. And now here's our SSH session into our Linux instance. The first thing we have to do is create a mount point. So let's create a directory called EFS to use as the mount point. Now we can paste the attach command from the clipboard. And we see here the file system is successfully mounted as expected. And doing an ls, we see that it's currently empty. Let's download some data from an S3 bucket just to provide some sample files that we can take a look at. All right, and as we can see, the download is complete, and we now have several files and folders in our EFS file system. A refresh in the console shows that the file system has automatically expanded. So we saw how simple it was to create an EFS file system. Great job at following along there, and I'll catch you in the next video. So we have gone over AWS's block storage and file storage. So now we're going to be talking about Amazon's S3 service, which is one of their core services. We have all pretty much leveraged this service in one way or another, either knowingly or unknowingly. For example, the images that you see displayed throughout Amazon's shopping website are stored in S3. As a matter of fact, during our very last video, when we pulled down some sample files to populate the EFS mount, those files were actually stored in one of my S3 buckets. So what exactly is S3? Amazon's Simple Storage Service is an object storage service that offers industry-leading data availability, security, and performance at a very high level. The service lets you store files as objects inside of buckets. Users can upload files inside of these buckets and the files can be up to 5 terabytes in size. S3 buckets are the unit of organization within S3, and they have a universal namespace, meaning that the bucket name must globally be unique. When you create a bucket, it will have a set of settings, and then any file that you drop in there can have those settings applied to it. There are different storage classes for different use cases, and we'll dive into each of these in just a bit. One key differentiator between block storage and object storage is that EBS volumes are primarily used for data that's constantly changing, but object storage is meant for data that's pretty static and doesn't change too often. This makes S3 a perfect candidate to serve as a static web host, and the content that you see on several websites actually leverages S3. One additional concept for S3 is S3 transfer acceleration. This feature enables you to upload data into your bucket much faster by utilizing the AWS Edge locations as a part of Amazon's CloudFront service. This takes advantage of AWS's backbone around the globe. So if you need to upload your data in a very fast and efficient way into your S3 buckets, you can consider utilizing S3's transfer acceleration service. As mentioned earlier, there are several storage classes within S3. First, we have S3 Standard. By default, if you upload a file to S3, it will have the S3 Standard storage class applied to it. The Standard class is one of the most popular ones because it gives you a lot of availability, as you can see, and 11 nines of durability. The durability here basically means the odds that your files are going to be lost. And the reason for that is that Amazon actually mirrors or multiplexes your files across multiple availability zones. That's why it's highly unlikely that you're going to lose your files. S3 Intelligent Tiering is a special storage class that will allow you to move your data to a correct storage class based on usage. Intelligent tiering is the only way that you can automatically move data between different storage classes based on access. It has 2 different classes associated with it. The first is frequent and the second is infrequent. So it'll move your data back and forth between those 2 different classes. It pretty much gives you the same performance as you get with S3 Standard, but it provides an additional cost savings. Next up, we have S3 Standard Infrequent Access. If you have data that's not frequently accessed, you can get a lower cost by utilizing this particular storage class. It still has the standard resiliency because it leverages multiple availability zones. S3 One Zone Infrequent Access, on the other hand, is for data that's not frequently accessed, and the data is only stored within one availability zone. So you get a much lower cost point than you do with the other options. However, you do have less resiliency. As you can see, it only offers 99.5% availability, as there's the chance that data can be lost if an AZ has major problems. S3 Glacier was designed for long-term archival. So basically, you should select this class when you can tolerate a longer period of time to get your data back than the previous classes mentioned. But recently, AWS offered a newer Glacier storage class known as Glacier Instant Retrieval class. And this class does deliver the fastest access to archive storage. Data can be retrieved in milliseconds. On the other hand, S3 Glacier Deep Archive is the cheapest storage option overall, but data retrieval can take up to 12 hours. But among all classes, this option has the highest availability of 4 nines. So as you can see, various storage options are available to suit the needs of your situation. Now let's quickly discuss the S3 lifecycle policies. This is an approach that allows you to transition based on your own custom criteria. Now it's important to note here, you can't move something back and forth based on usage. That's only available with intelligent tiering, but you can do it based on time. And you can also delete objects with expiration based on age. So let's say, for example, you had a certain file that you only want it to last for 15 days. You could configure that using lifecycle policies. Additionally, the policies can factor in the concept of versioning. For example, you could say something like delete a version of a file that's not the current version after 5 days. So those are a few of the different things that you can configure utilizing S3 lifecycle policies. So let's hop into the console and create our very own S3 bucket. In the search bar, simply search for S3 like I'm doing right here. And when you click on S3, you can see that this is a storage service. On the home page of the service, you get a wealth of information about S3. So take the time to explore and read all about it, as it's a very convenient place to do so. Now, if you click on buckets from the left-hand navigation menu, you should see that you have no buckets created. So simply click Create Bucket, and you can see that we must first provide a bucket name. Recall from our last session, this must be a globally unique name. I'm going to enter NYK hyphen, and let's see, my initials, and I'm going to put a few random numbers. Putting random numbers just decreases the likelihood that someone already has this bucket. And for the region, I'll stay in the US East 1 region, which we've been doing so throughout the bootcamp. For object ownership, I'm going to change this to select ACLs enabled, which will make making this bucket public a little bit easier to configure here in our demonstration. But keep the option for object ownership as the default. And next up, this is where you have the option to provide public access to your bucket or block all public access, right? So here's the thing. There are a few cases where you have public files that you know you're okay with being accessed over the internet. For example, if you're creating a bucket for an e-commerce website that has a lot of features, then those features need to be made publicly available on the e-commerce website, right? Or else no one would be able to know what they're purchasing. And so in those cases, you can simply create a public bucket, and then you can enable the public to be able to access the files, such as the photos of the items that you're selling, just like Amazon does on their website. And one of the primary reasons is because there's simply nothing confidential in there. But on the other hand, if you're creating a bucket to store sensitive documents from your company or backups from your application or database, for those kind of things, you should probably never give public access to those buckets. In that case, you would keep the block off public access as it is. Otherwise, people over the internet with the link to access your file would be able to do so inside of the S3 bucket, right? So the key thing here is to understand when you should allow the public access and when you shouldn't. But for now, I'm going to allow all public access because we're going to upload a PDF and we're going to see how we can provide public access in addition to this setting right here. So uncheck this and you see that it's going to give me a warning saying that AWS recommends that you turn on block all public access for the reasons that were just explained. But in our case, let's simply acknowledge this warning because we know what we're doing for this demonstration. You can also enable bucket versioning. It's a pretty nice feature that allows you to basically allow S3 to store multiple versions of the same object. So for example, you're going to upload a PDF file and then later on, maybe you have a different version that you want to make the current version available, but somewhere down the road, just in case you ever decide to go back to it, maybe customers don't like the new data that's there or you're not getting a lot of attention, then with version enabled, it makes it easier to simply revert to that original object. Or even if you have 10 different versions, you'll be able to select them here. So we're going to enable it here. We'll skip tags for now, and also we're not going to enable encryption, although you should do both of these in production buckets because it's going to help you with adding security to make sure that you keep your data safe. Now here in the advanced settings, you can enable the objects locks, but we're not going to enable that as well. So let's simply click Create Bucket. Our bucket is created and we can see that our access allows the objects or files that we upload to be publicly accessible, which is what we want for our demonstration. So click on our bucket name. If you look here, you can now begin uploading files to the bucket. So let's click on Upload. So here you can either click Upload to manually select the file or the files that you have, or you can simply drag and drop the objects over here, which I'm going to do. So now you can see the file is ready to upload, the PDF that you can see right here. So let's go ahead and click on Upload. We see here from this screen that the file's uploaded successfully, but let's hit the X to close this section. Now let's see if we can access the file over the internet through the public URL for our object. So let's click on this hyperlink that S3 provides us. And from this message, it looks like our permission is being denied. So although we made our bucket publicly accessible as an extra step in security, the way we have ours configured, we must also make the object public. So to do so, simply click Permissions tab and then click Edit. Now we'll check the box for read access to this object for everyone and acknowledge the effects of this change. Then click Save Changes. Now let's click the hyperlink again. And so now it looks like anyone with this link can access the PDF over the internet. Pretty cool, right? So that's how you control the permissions on your S3 bucket, right down to controlling it in the object itself. Pretty easy, pretty straightforward. So now let's take a very quick peek at a few of the other tabs. Here under metrics, if we were to come back here and say 30 minutes or really any time after that, we would see different metrics begin to populate. But since we just created the bucket and uploaded the file, it's blank for now. On the management tab, you also have the lifecycle rules that can help you move objects in different storage classes, which will help you save on S3 costs. Likewise, replication rules to replicate the data across different regions. Now let's go ahead and delete our bucket. And to do so, we have to first delete the object. So let's highlight it and then click delete. Let's go ahead and enter this to basically confirm that we want to delete it. All right, let's click this and then wait a few seconds. All right, so our PDF has been deleted. So now let's go back to the bucket. We'll do the same thing. But we see here that we need to enter the bucket name to validate our choice of deleting the bucket. So I'll simply copy the name, paste it here, and then click delete bucket. And as you can see, when we go back to our buckets, we're right back to where we started. But that's how you can create a bucket and upload objects that can be shared publicly or kept private for yourself, depending on your use case. So definitely feel free to hop in and get your hands dirty. Try this out for yourself. And it's definitely one of the core services that you will want to understand for yourself. So take time to do that, and I'll see you in the next video. So let's take a look at a quick overview of the demonstration that we have this module. We saw how important the S3 service was, as well as how flexible it is with providing access to objects over the internet. In this demonstration, we're going to show how you can host a static website on AWS inside of an S3 bucket. First, we're going to need to upload some static files, which consist of the HTML code, which will display the contents of our web page. These files will be uploaded into a public S3 bucket and will use the public DNS name to access it across the internet. We saw in an earlier module that there was an option to enable static web hosting, and although we did not enable it for that lesson, we're gonna need to enable it for this demonstration. Once we have that all set, then anyone across the entire globe can make an HTTP request to the website and it'll be visible inside of their browser. So this is just another level to demonstrate and explore, as there are so many use cases for the different storage services available inside of AWS. So now it's time for our S3 hands-on demonstration. And in this short demonstration, we are actually going to download a zip file that contains all the elements that you need to upload to your very own S3 bucket. Once you unzip those files, you're going to see that the contents are really the various elements that you need to create a static website. And as we mentioned earlier, for content that doesn't change a lot, which when we use the word static, that's what we're referring to, then S3 buckets are the perfect location for that. And so here, let's go ahead and take a look. If you, of course, unzip that file, this is going to be what you see here, an index.html file, and of course, an assets folder that has some images here. But taking a look at this index.html file, we see some code here in the header, just some jQuery being used. And if we scroll down, really just a combined the HTML as well as the CSS, which styles the page and provides not only the color, but the padding and alignment and the size of the words and things like that. It's all contained within this one file. And in full transparency, I actually created this page myself, and I'm not a web developer, so I definitely have a long ways to go, but just wanted to challenge myself and continue to grow my skill set and put this together. So again, this is what you'll have in that zip file. But as we can see here, we call out those assets that are, of course, contained in that asset folder. So when we see it here, a few steps down the line, this is just really what the page do. A very simple website, and you can actually play around with it on yourself. In Visual Studio Code editor, we We used this early on in one of the earlier modules, but we can see how a lot of the tools that you'll use as a cloud professional are gonna not only work for just one thing, you can use them for multiple different occasions. So definitely get familiar with them and continue to test the boundaries and test yourself as well. So let's go ahead and head back to the console. All right, here, so we got a blank slate right here. So let's go ahead and create a bucket. We'll click here on create a bucket. We'll give this a name. Let's say www.nyf. Let's call this demo 2023. Hopefully no one has that name again. Need a global unique name. We'll keep it in the US East 1 region. And for the object ownership, we'll change this just to make it a little bit easier. We need to make this publicly accessible, of course, to reach it across the internet. We'll acknowledge this, and we'll go ahead and enable bucket versioning, and we'll leave decryption as a disabled for now. And let's go ahead and create that bucket. Again, that process is pretty quick, as we saw early on. So we see that objects can be public. So let's go ahead and click in our bucket, and we're going to upload our assets here. All right, so let's see what we got. So again, we have the HTML and of course the assets folder. So I'm gonna go ahead and highlight both, drag and drop both of them in, and we're good to go. So let's go ahead and click upload, and let's see. We can change this ACL right here. Skip a step so that we don't have to come back. All right, let's see. We'll close this right now. And so there we go. Let's see if these objects are public. We'll select both of these and then we'll make them public using an ACL. There we go. All right. Now we need to, let's see. Now we need to enable, let's see, it's going to be way down here, static website hosting. We'll click edit, static website hosting. We'll click enable. And right here, we can leave this again, index.html. We'll go ahead and type that since that is the name where we want the landing page to be for these requests. We'll hit save changes. Give that a few moments. All right, let's go back to our objects, and on this index.html, we'll click in here. And as we can see, we have that object URL. So right now, if we right click and open the page in a new tab, then we actually that quickly have a website here, static website that's hosted across the internet. We could provide this URL to anyone, a friend, a colleague, someone that wanted to do proofreading or anything like that. And just, again, easy breezy, simple website here. And like I said, you can take the time to play around with the code, change up the colors or the logo or anything like that, and definitely expand your skill set there. But that's really all that was needed to do that. So definitely was pretty cool doing that. And let's see what else we can do while we're in here. One thing that we didn't mention in our last lesson is actually creating a policy to protect. This, again, allows public read access to anyone, but we need to provide some further protection so we can actually place a permission on this policy. So let's go ahead and go back to our bucket. We'll go to properties. And again, for the transfer acceleration, we don't need to enable that right now. We don't have a CloudFront enabled, so no issues there. But underneath permissions and bucket policy, if we click on edit, then we see here that AWS actually has a policy generator right here that'll help us out. So if we click there, it'll open up in a new tab. And if you're not too familiar with JSON, that JavaScript object notation, then this will help you kind of walk it through in plain narrative, so to speak. So we want to create an S3 policy, bucket policy more precisely. So we'll click there. And the effect is we do want to allow access. So we'll leave that. And for the principal, we want this to be a star. Anybody basically on the internet. And the actions, again, right now, we just want them to be able to do a get object to basically request the website. So we'll select that. And then for the ARN, if we go back to our bucket, it's actually right there. So we'll copy that. And what we need to do to provide access is to do a slash, a forward slash, and then a asterisk or a star, so that any of the objects that are contained in the bucket are actually allowed to be requested as well. So if we hit add statement, generate policy, we're going to go ahead and just simply copy this bad boy, go back to our policy, paste it on in, and then save those changes. And so now we're providing further protection to our bucket policy so that no one can do any kind of like hanky-panky and try to see other objects that they shouldn't be reading if someone were to upload something afterwards. So we can see that if we come back here and refresh, still allow access. One final thing to demonstrate, again, if we were to go to CloudFront to provide quicker access globally. So let's say folks out in Australia or Singapore or in Europe were accessing the site right now, because this is in the US East region, they would probably experience some latency. But of course, we saw earlier that AWS has plenty of locations in different regions and edge locations around the globe. So we see here that now for the origin domain, let me zoom in just a bit. Because we have that bucket and we edit it to enable it to be a website, we can select this, and we won't go forth and do this, but this is basically the many options that you have. You can use Origin Shield to provide some security protections against malicious items there, default cache behavior, so that because this is a static website and things don't change, if 1,000 requests were made a day, we can just basically cache this home page here, so that because it's not changing, they will make a single request that's already cached there locally to kind of save on some processing there. Just tons and tons of options. You can save some money here by, depending on the location that you want this to be, CloudFront to serve it. In those edge locations, you can make filters there. And of course, AWS's web application firewall protects against many of those malicious attacks at the layer 7 application layer there. So pretty cool. Lots and lots of options. But like we said, we'll cancel out of here. And again, in this hands-on demonstration, we saw that it was very simple to go ahead and host a website there on an S3 bucket. So hope you enjoy this. Like I said, your knowledge, your experience, and just all that you've learned thus far through each of these modules that, of course, build upon each other. Definitely come a long way. Definitely continue to be a superstar, and super proud of you. And I hope, like I said, that you found value not only in this lessons, but the others. And we're almost there. But again, we got a little bit more ways to go. So I'll see you in the next video. Okay, real quickly, let's go ahead and clean up our environment. Again, we did do EBS, EFS, and S3 during this module, but we ended up, of course, with our public website here in the S3 bucket. So let's go ahead and change back or navigate to S3. Let's go ahead and simply search for S3, and we'll go directly to the bucket. Okay, and as we know earlier, we need to get rid of those objects before we can delete the bucket. So we'll simply check this box to check both. We'll click delete, and then let's go ahead and delete these. Of course, as we can see, because we have versioning enabled, we can restore these items. So when we go to the bucket, we do need to perform an extra step. So we'll go to bucket, We'll select it and let's empty. And then we'll need to type or copy permanent delete. Again, I'll choose the latter. I'll copy and paste right here, click empty. And now we can go ahead and get rid of our bucket. So one last time, select that radio button, and now we'll select delete. And of course here, we need to type the bucket name. This of course was what I named mine during the demonstration. Paste it in and delete bucket. And of course, this is where we come when we're all clear and clean, but we'll just validate that there are no buckets here. And just for sanity's sake, let's go ahead and check out EFS. See if we've got anything lingering there. Again, you may have explored a little bit offline, so it's always good. But if you see this screen here, typically with all the information about a service, it's pretty good indication that you don't have any file system. So double check there, nothing there. We'll see here. And then last but not least, underneath EC2, again, we're still underneath the free tier eligibility. As long as you keep the storage low, like 8 GB, and of course the number of hours, I think it's currently 750 for the T2 micro. So I still have my Linux host here, and that's the volume that's there. No snapshot. So good to go.